Class 10 students, welcome to Diksha Vedantu. A very big time for all of us. Time is ticking really fast and your PT1s are already here. So beta, this video is for all of you people who, if you have revised the whole syllabus, very good. This is a revision video because we are going to do lots of questions along with the full one shot. So in this whole package, you are going to get everything starting from the basics of what light is to the very advanced questions and numericals of mirror, of refraction or of lenses as well. Okay, so watch this video till the end and subscribe the channel. Now, I was talking about if you have already revised this chapter, this video is a revision one shot for you. But if you have not done literally anything till now, then also this video is a short solution of all your doubts, all your concept clarification, every numerical of the chapter light that you think, that you fear, all the ray diagrams, everything is covered in this particular chapter. Okay, beta. Now, we started with a very light note that you must have seen these pretty sunsets and these fairy lights in your rooms, or these aurora borealis we call it, or if not with your naked eyes, you must have seen these beautiful pictures of galaxies out there, right? And we all have a dream of visiting there. Now beta, what is the one thing that is common in all of these? Ma'am, the one thing that is common is light. And obviously we can see light through our eyes, but if you turn all these lights down, and now can you see anything? Although your eyes are open, but you can't see anything, right? Why? You can see all these things beta because of this magical thing called light. So what exactly is light, ma'am? We know that light is something which lets us see the world. But what exactly is this is the first question that pops us in our mind, right? So beta, we will start with the very first, very basic thing. What is light? And then we'll move on to so many questions, because see, if you don't do any questions, especially in this chapter, if you don't understand ray diagrams, if you don't understand numericals to their core, it won't be of any use. Okay, you can understand all the concepts, not doing numericals, it will be of no use. So in this particular lecture, you will get everything that is there that you need for your even class 10th boards. These are just PT1s. So we are going to quickly revise and quickly cover this whole chapter. Okay. Now beta, starting with what exactly is light. This is the complete outline of this whole chapter. We'll start with what is light. Refraction, power of a lens. We all know that. Now beta, exact question is what is light? It is a form of energy that enables us to see this pretty world around us. That's it. That's the definition of light. Now, after we understood light, every time, even if we studied, you remember atom or cell in your 9th class, we studied and asked, what is exactly atom made up of? What is exactly cell made up of? So naturally, we as a human being, we asked, ma'am, what is light being made up of? Then every scientist sat there and they started thinking, okay, what is light actually made up of? So who came? Our very own Newton Babaji. Newton Babaji came and he said, light is made up of a particle that is called corpusculus. He called that particle as corpusculus, right? And now we call that particle as photon, right? Now, that theory came along, it came along and it went for a long time. And then came Huygens ji, Christian Huygens. He came and he said, hey Newton, I think it does not act as a particle. It acts as a wave. What is a wave? It acts as a wave, right? It's not acting like a particle. Now wave, it consists of electromagnetic wave. It has electric waves and magnetic waves in it, right? But Newton said it's a particle. So now what is the conclusion? What is the conclusion of this whole battle? The conclusion came that light beta, it has dual nature. What does that mean? It acts as a particle whenever it feels like. It acts as a wave whenever it feels like. Now we know when it feels like particle, when it feels like wave, but at that time so many experiments were happening. So we simply concluded that light has dual nature. It acts as a particle and it acts like a wave according to the situation it is presented into, right? So basically, when you see solar panels, we are doing what? We are attracting all the light from sun, and let's say we are collecting all that light on solar panel, or we are using solar cookers. So what we do? In that case, we are collecting photons and they are ejecting electrons, and that is giving us photoelectric current. Too much stuff, ma'am. Wait. Basically, in solar cells, in solar panels, the light is acting as a particle. That's all you have to remember. And beta, in some other cases like prism, we will read about prism, right? In the next chapter, we will read about prism, right? So in that case, we will do Young double slit experiment. It is very interesting. In that case, light acts as a wave. It acts like a wave. So basically, light acts both as a wave and a particle, and it changes its behavior according to the situation it is presented with. Understood? Till here everything clear? Now after that, beta, we have to see one thing. That is, why do we see objects? Ma'am, I open my eyes, I see some objects. Yes, but if you close your eyes, if I close all the light from here, the objects are still here. Why do we not see them? Right? The main, what we started with, right? That is, beta, because the light is entering directly into my eyes, but it is also bouncing on that screen on you, and then you, from bouncing back from you, it came directly into my eyes. Or let's reframe this. This light, it hit me and it bounced and it hit your eyes, right? That's how you see me. That is a form of reflection of light. It is called reflection of light. That is one of the main topic of this chapter. It is the bouncing back of light in your eyes. Okay? So it's bouncing back of light when it strikes a surface without being absorbed. If I absorb all this light, then will I be visible to you? No, because no light is coming from me into your eyes. Then I won't be visible, right? Maybe, ma'am, that's a trick to be invisible, to absorb all the light. Maybe, who knows? Maybe you can do some research on that, right? So that is, beta, the main principle of reflection of light. Understood? Now, let's dive a little bit deeper into science. Now, we were studying about a little bit more about common things, okay? Let's dive a bit deeper into physics, okay? Now, beta, talking about that, we have two laws of reflection. One, when I'm saying that this light is hitting me and it is going towards you, then there is an incident ray that is hitting me, and from me, the bounced back light, it is hitting your eyes. So this light that is hitting your eyes, it is called, now this is called incident ray. The light that hits me and come into your eyes is called reflected ray. Understood? See very carefully. Now we will be dealing with mirrors, okay? Take me out of the picture and place a mirror in front of me. If this light hits the mirror and then it goes into your eyes, then these laws will be applicable. Actually, these laws will be applicable on me also, okay? But it is easier to understand reflection with mirror, right? We can see the rays, we can see the thing that is placed in front of the mirror. Okay, so that is it. So we are going to study about laws of reflection. Now, beta, these are very important. You have to remember all of these by heart. They will directly ask you these questions. Write down the laws of reflection. Okay, so these are the two things you have to write. Let's understand them. Now, you took a mirror. Okay, you took a mirror. Let me just take this. Like, this is my phone. Okay, this is my phone. Now, one incident ray came, and from this phone, from this mirror, it reflected back. It will do something like this. right? Similar to this. So this is incident ray. It came, it reflected from this mirror and it bounced back from this mirror and it reflected back. Now this beta is my incident ray, right? This is my reflected ray. Now up till here, ma'am, we are clear. Now we know that there is one very important thing, that is normal. Even in your 8th classes, you have studied about contact forces, right? Contact forces. So that is not much of use here, but there is one force called normal force in contact. When two things are in contact with each other, they apply normal force, right? All that stuff. Now similar to that, not much, but similar to that, we have one normal here as well. But this normal is not that force. It is not a force. It is simply, beta, see, this incident ray is hitting this particular point, right? Now if I draw perpendicular on this incident ray, incident point, if I draw a perpendicular upwards, a perpendicular upwards on this incident point, so this angle is 90, this angle is 90, okay? And this normal ray makes an angle with this incident ray that is coming. It is making an angle with incident ray. Now this angle, beta, this is called angle of incidence. And similarly, this normal ray is making an angle with reflected ray. This angle, beta, it is called reflected angle or angle of reflection, angle of incidence. Clear till here? Okay. Now one more thing you have to remember. So that is your first law. The first law says this angle of incidence is always equal to the angle of reflection. Then only reflection will happen, or wherever the reflection is happening, you have angle of incidence equal to the angle of reflection. Clear? Then beta, one more thing you have to remember, this incident ray, this reflected ray and this normal all lie in the same plane. That means if my incident ray is coming like this and reflected ray is going like this, then my normal will not be like this. It will also be like this, perpendicular to the surface. Done. So they all will lie on the same plane. See, let's say this is a plane, okay? Incident ray came, reflected ray went, and this will be the normal. The normal will not be like this, coming out of this plane, okay? Done. So that are the two laws of reflection. Let's read it. The angle of incidence is equal to the angle of reflection. Done. Very easy. Then beta, we have the incident ray. The incident ray, the normal to the mirror at the point of incidence. The normal to the mirror at the point of incidence and the reflected ray, all of these will lie in the same plane. Done? Easy? It was easy. Okay? Now beta, after this we are going to study image formations. We are actually going to study about something called optical instruments. Something called optical instruments. Now in these optical instruments, beta, technically in this chapter we have two parts. First is what? Reflection, and second we know it is refraction, right? It is refraction. Now both of these are very different, so make sure you know that. And beta, this will come in your periodic tests, we all know that, so make sure you do this chapter with full attention. Okay, back here. Now beta, optical instruments, reflection, refraction, we are studying now reflection. Now you tell me, light is bouncing back, going into your eyes. Do you know that some kind of optical instrument that do that? That is our mirror. You wake up every day, you brush your teeth, you comb your hairs, you put some makeup on, and you do all those things. You check your outfit, you make a get ready with me video. So where do you do that? You have a mirror, and that mirror is reflecting your image. That mirror is reflecting you. The light rays from you are going into the mirror, and then from the mirror all the light rays are coming and hitting your eyes, and hence you can see the image in the mirror, right? So beta, that is not the only mirror in existence. You have seen some mirror shows or places where you go, you will see your head got bigger, your thighs or the lower body part got smaller. How is this happening? How is my body is looking so small in that mirror? That are not the same normal mirrors. Those are different kind of mirrors that we are going to study in reflection part. Okay, this is the first part of your this whole lecture. Okay, now beta, reflection, let's study about the first basic, that is your plane mirror. Okay, plane mirror which we use in our houses normally to get the things done. Okay, now beta, first thing is, in the mirror, do you see, in the mirror you have at home, do you see that you're taller, that you're smaller? No, you see the exact same height, right? So the first property is the plane mirror. The plane mirror that we have in our houses, the size of the image is equal to the size of the object. I am the object. The image of myself I see in the mirror is the image, obviously. So my height or my size will be will be equal to the height of my image, right? So the size of image is equal to the size of object. That is clear. Then beta, in this very important thing you have to remember that in plane mirror, your image is formed behind the mirror. What do I mean by behind the mirror? That you will see in later that in concave mirror you need a screen. That means there is a mirror, but the image is formed on a screen, not on the behind the mirror. But in plane mirror, you will see that you are here, right? And the image is formed behind the mirror. As we go into the chapter, you will understand this point better. Okay, so make sure bear me for some seconds. Okay, then beta, we have the image is laterally inverted. That means my left hand will look like my right hand and my right hand will look like my left hand. That is pretty much clear. We know that, right? But the word for that, we know that is true, but the word for that is laterally inverted. Okay, now beta, one more thing you have to remember, and I will explain you in detail what virtual and erect means, but let's move on to concave mirror for now. Okay, you will understand this thing better in concave mirror and convex mirror part. Okay, let's move to the next part, that is your spherical mirrors. Now why do we call these spherical mirrors? Because they sit like this, like you are sitting right now, like this, like a curved surface, like a C, right? Like this man right here, right? Oops, this, right? And that is what our spherical mirror is. So you won't forget that ever. Now beta, what actually physically it means that the reflecting surface of a spherical mirror may be curved inwards or outwards. That means in plane mirror we have a same kind of mirror, right? But in spherical mirrors or in the mirrors which are curved inwards or outwards, we don't have this plain sheet of mirror. We have mirrors like this. We have mirrors like this, right? And that is what we are going to study in reflection. It's a bit longer part. Okay, now beta, we have two types of these mirrors. First one is your concave mirror. Now in concave mirror, if the inward side of the circle, you remember it like this, you have a circle. Okay, if this inward side is reflecting, that means light rays are coming like this and are bouncing back from here. That means this is the part where you can see yourself, not this one is the part which is the behind of the mirror. Then that mirror will be called concave mirror beta. And how will you remember that? Ma'am, we will remember that using this word cave. That means this looks like a cave to you, something going inward. So it's like a cave for you, right? You can go in, right? So that is concave mirror for you. That means it is like this, and the outward part, this is the polished part, and in here this is your reflecting part. This inward part is your reflecting part of the mirror. This is the mirror, this is the side of the mirror where you will see the image. Done. The spherical mirror whose reflecting surface is curved inwards. It is curved inwards, that is faces towards the center of the sphere. If we complete the sphere, this will be the sphere and this faces the center of the sphere, right? So it is called concave mirror. Understood? Next beta we have convex mirror. Second one is convex mirror. Now just the opposite of that. That is a cave. Light is going inwards. It is the other side of the cave. Convex is the, see, this is the inward side, right? But now the light is not hitting the inward side. Light is hitting the outside. Light is hitting the outward part of this mirror, and that is beta called convex mirror. A spherical mirror whose reflecting surface is curved outwards. So this is your reflecting surface, this whole surface, and this part, the inward part is polished. Here the outward part is polished, right? And this is the part where image will be formed. Here this outward part is the part where image will be formed. Understood? Clear? Everything clear, right? Now let's study the image formation by spherical mirrors for both concave and convex. Now, right before jumping into these rays, from where the rays are coming, where they are meeting, let's just look at the terminology. Okay, see beta, this C, the C, that is your what? Center of curvature. This is very important. You have to remember all these things. Center of curvature. F is beta your what? Focus, right? Then this small f is your focal length. It is simply your focal length, which is the distance between this mirror and half of the center of curvature. Half of the center of curvature. You know this, right? This is your mirror, right? And this is how you complete the circle, your sphere, and this is the center of sphere. So the center is called center of curvature. This is your mirror. It is a convex mirror. That means light is hitting on the outside part of this mirror, right? So this is your half of this radius. This, see, this is center. If I join this will be radius. So this R beta, it is called the radius of curvature. This R beta, it is called the radius of curvature. And half of this radius, this whole radius, half of this, you will have a point called F, that is your focus, and this point, from this point to the mirror, not towards the radius, to the mirror, not towards the center, towards the mirror, that line joining is your focal length. Understood? And the line that is parallel or cutting the mirror into half is your principal axis. Done. So we have concave mirror whose inward part is reflecting. We have a convex mirror whose outward part is reflecting. Outwards part, light is coming like this. Outward part is reflecting. Light is coming like this. Inward part is reflecting. Understood? Okay. Now beta, we have some few rules that we have to take care of while drawing the ray diagrams, as we call them, right? There are 4 rules for concave mirror, right? For concave mirror, we have 4 rules. What are those 4 rules? First beta, whenever the ray is coming parallel to principal axis. Now see carefully, this is your concave mirror, inward part is reflecting. This is your center of curvature, half of that is your focus. Done. And beta, this is your principal axis. If this incident ray if this incident ray is coming parallel to this principal axis, now these two are parallel, right? Parallel to principal axis, then it will reflect and it will pass from focus. It will pass from focus. Understood? That is the first rule. Second rule, beta, now just the reverse of this. If the incident ray is passing through focus, it is passing through focus, then it will reflect, it will get parallel to the principal axis. Then a very silly, that is, if this ray is passing through center of curvature, hitting this mirror, then it will reflect back and it will follow the same path. It comes like this, it reverses back and goes back like this only. Then next, beta, we have simple but very important, that is your pole. So if on pole these rays, they incident on this pole, right? On the point where the principal axis touches the mirror is called pole, right? It goes back, and this incident angle and reflected angle will be equal. Done. These are the 4 rules. Now let's finally move towards image formation. The very first case, beta, that is your infinity. Now we take a concave mirror. The light will be coming and bouncing on the inward side. Here we have center of curvature, here we have focus and pole and all those things. This is the principal axis, right? Now, beta, what we see is like, okay, I want to see everything. From concave mirror, if an object is very far away at infinity, then where the image will be formed? Then we say, okay, let's see. Now, beta, when the object is very far away, we assume that the light coming from that object is parallel to principal axis. All the rays coming from the point that is at infinity, all the rays will be parallel to this principal axis. Done. All the rays are parallel to principal axis. Now what will happen? Now is the time where you should understand some things. What are those things? Beta, 2 or 3 more things you have to remember. What are those? Very simple. See, concave mirror. Okay, concave mirror. Now one thing is, this is your mirror, right? And this is the polished side. And this is sphere will complete like this. So center of curvature will be here, focus will be here, this will be your principal axis, this will be your pole and all, right? Now all these things are here. Now, beta, one thing you have to remember is this side of your mirror will be your left hand side. This will be your left hand side, right? And this, beta, will be your right hand side. Done. Now, why I am telling you this? Because, beta, whenever we are passing a parallel ray, it will pass from focus and it will come back and it will pass from focus. Understood? Okay. Now let's quickly see, and at the end we'll see all the sign conventions also. Okay. But before that, you have to understand these ray diagrams. Okay. Now this will hit the mirror and it will reflect back. Passing from focus. It will reflect back passing through focus. It will reflect back passing through focus. Reflect back passing through focus. So these all rays passed through focus, center of curvature, your pole. Understood? All this ray diagram completed. Now 3 things you have to take care of. Okay, whenever you are making a diagram, you have to write some things, the nature of image formed, the size of image formed. So first of all, the object, beta, is at infinity. The object, beta, this is the object, right? So object is infinity. Where the image is formed? Image is formed where all the rays are meeting, that is your focus. So beta, the image is formed at focus. This is what? This is your image distance or position of image. Done. Next, beta, remember, this is what? A small sized image. So we have to write the size of image. That will be your we have to write the, oh, I don't know how to do this back. Oh yes, okay, so sorry for that. Yes, let me delete this. Yep. Okay, so we have to write the size of the image, right? Now size of the image is but a very small, point sized. So the size of the image is point sized image. Done. So we wrote about the size, the position of the image. One more thing we have to write about, that is real and inverted. Now I will let you know the first part, that is real, and inverted in the second case. You will understand it better. Now beta, see here, a real ray is coming and this real ray is getting reflected, right? This ray came, now this is only getting reflected back, so the real ray is getting reflected. That is why this image is real. Okay, and it is inverted as well. We will understand this in this case. Okay, so for now this is the whole scenario of the first case. When the object is at infinity, image will be at focus, it will be point sized, it will be real and inverted. Why real? Because real rays are reflecting back and actually meeting, actually converging at one point, and that is why we call concave mirror as converging mirror. Converging mirror means all these rays, they are meeting at a point, that is called converging at a point. So that is why we call this concave mirror as converging mirror. Done. Next beta, let's see the second case. Now beta, we what did we do? This was our concave mirror. We left the object at infinity. This is here, somewhere here. Now we brought it a little bit closer, where we know we have center of curvature, right? We have focus, we have pole. So here we brought it beyond C, that is beyond the center of curvature. So this beta is my, let me keep the color same. Yes, this is my object. Okay, this beta is my object, that is where beyond C. Now from this object incident rays will go. How? Now first ray will go parallel to principal axis. It will go parallel to principal axis. This is parallel to principal axis. From where it will pass from? It will pass from focus, right? So it will pass from focus. Okay, this is your reflected ray. Okay ma'am, then what? Here where the image is formed, we need one more ray. We studied one more rule, right? When this ray passes from focus, it becomes parallel to principal axis after reflection. Now that means it becomes parallel to principal axis after reflection. Understood? Now the point where this is meeting is our image. So this beta is your image, and image is where? Ma'am, image is between C and F, between center of curvature and focus. Understood? So when the object is beyond C, your image beta is between C and F. So let's write about this, right? Now this was your object, right? This was your object. Now let's write about the image. Ma'am, image will be between C and F. It will be between center of curvature and focus, just like we have drawn. Okay, then beta, we have to write about the size. Now you can clearly see it's a little bit smaller. This is a little bigger. This is a little bit smaller, right? So we write in physics, we give it the name as it is a diminished image. It is a diminished image. Diminished beta means smaller. Diminished means this image is smaller than the object relatively. Okay, this image, size of image is less than the size of object, and hence it is diminished. Now see carefully, this upper part, from this upper part rays are going and meeting at a point. Upper part rays are going, meeting at a point. So this upper part, this arrow will be at this lower half, right? And from this we know that if any ray passes from center of curvature, it will move back and trace the same path. So the light from this end comes back, so this point will be the lower end. This point and this point both will be the lower end. Understood? So that is why the image is reverse. It is inverted, and that is why we call it that. Again, real rays are meeting. So this image is what? This image is real, and I can clearly see that this image is inverted. This image is inverted. Done. Okay, so we wrote about the position of image between C and F when the object is beyond C, it is diminished, and it is real and inverted. Done. Okay, let's move to the third case, that is beta. Now our object was infinity beyond C. Now we move it a little bit closer at C. So we place it at the center of curvature, on the center of curvature. So this beta now is your object. This beta now is your object. Done. Now from here again the same kind of rays will go, right? A ray will go parallel, okay, and it will pass from focus. It will pass from focus. Understood? Then beta again one more ray will go and it will pass from focus. It will pass from focus, right? And when it reflects, it will become parallel to the principal axis. It will become parallel to the principal axis, right? Something like this. And if you make the image, if you join the image, and this will be something like this. Okay, you have to adjust it a little bit. Actually, in this case, the image will be, we have to remember that at C, whenever the object is at C, the image will also be beta at C. You have to trace this rays a little bit. That I will tell you the trick, no worries. Because every time you can see we did everything right, but every time sometimes a little bit here and there the rays will go. Okay, so you have to fabricate that a little bit. But we know that the image that is made at the center of curvature the object when placed at center of curvature will have image also at center of curvature. So this is your object, this is your image. Now beta, this where the image will also be at center of curvature. In this case, the image will be of same size as of that object. Same size as that of object. The height of this object and the height of this image will be same, right? And the image will again be real and inverted. The image will again beta be real and inverted. Fourth case, done. Third case, done. Okay, let's move to our fourth case. Now in this beta, the object is between C and F. Now what we did, we have a concave mirror, we placed it at infinity, then we placed it beyond C, then we brought it much closer at C, then between C and F. Between C and F. So now this will be my object. This will be my object. Understood? This will be my object. Done. It is between C and F, and this is your pole. Now what will happen? Ma'am, again one ray will go parallel and it will reflect back. It will reflect back and pass through focus, right? Pass through focus. Then ma'am, again ma'am, one ray will go and pass through focus. It will pass through focus, and we will see that after reflection it will go parallel to the principal axis, parallel to the principal axis. Okay, and that is how beta, if you just extend it a little bit, yes, this is the point where these two rays are meeting. This is the point where these two rays are meeting, and hence beta, this will be your image. This will be your image. If you extend this beta will be your image. Now image is where? Image is beyond C. Image is, this is your object, right? Image will be beta, it will be beyond C. Understood? And it is very large. This is smaller. This is larger than the image. So it will be enlarged. It will be enlarged, and it will be real and inverted. It will be real and inverted. Now did you like see one thing? What happened? Our image was at infinity, right? So at the object was at infinity, the image was being made at focus. The object was beyond C, the image was between C and F. And here in the next case it's just reverse. When the object is between C and F, the image is beyond C. Can you see? Can you see that the relation has just reversed? Okay, and when the object was at C, the image is again at C. Done. 4 cases are already done. Okay, next case beta, our fifth case, when now again concave mirror, object at infinity, object beyond C, object at C, object between C and F, and now object at F, at the focus, right? So now beta, your object is at focus, on the point of focus. Again what will happen? One ray will go parallel, and after reflection this will come back and pass through focus. Okay, now there is one important thing. How will this ray pass from focus? It can't, right? So we have to use other two rules. What you can do? You can use the rule that either this goes from pole, okay, this passes from pole and it comes back like this, and we know this incident angle and reflected angle are similar. Okay, one more thing you can also do, you should know actually, is beta, this ray, this your ray, it goes like this. Okay, it goes like this, it will reflect back and will pass through your center of curvature following the same movement. It goes like this, pass like this from center of curvature. Okay, so you can also do that as well. Okay, out of these, this is compulsory, this parallel goes into the focus. From this, passing through pole and reflecting and going and hitting this mirror surface, turning back, passing through center of curvature. You can do that as well. Both are true. Okay, both beta are true. Let me just remove this. Can I? Okay, I can't. Okay, done. This is your focus, center of curvature, pole. And now see, these lines are going parallel. Parallel lines never meet. Parallel lines never meet. So beta, in this case, the object is at focus. This is your object, right? But the image beta, image will be not formed. Image will be not formed. If the image is not formed, how can we write the size and nature of the image? But still somehow we used to say earlier that the image will be formed at infinity, right? Where is infinity? Infinity is nowhere, so image is not formed. Done. Next beta, now it is at focus. Now the object jumped more closer to the concave mirror. Infinity, beyond C, at C, between C and F, at F, between F and pole now. Between F and pole now. This is focus, center of curvature, pole. Right? Now beta, let's see where the image is formed. That you will see that it is between pole and focus. Right? Now what will happen? Again, ma'am, one ray go parallel and it will pass from focus. It will pass from focus. Understood? Next, ma'am, what should we do? Let's do the center of curvature part. Okay, so you are saying, how do you have to draw this? first you will do this. You will do this. Okay. You will pass a ray from center of curvature. Okay, then only you will do one more thing, that is pass it from here. It is a little trick. Okay, so now this is your incident ray. It bounced back from the mirror and came back. Understood? Done? But ma'am, these are going away. We know concave mirror is a converging mirror. But in this case, beta, I like to call this a stupid case. It is a stupid case. It does not obey your rules of mirror. Maybe a rebellious case. Okay. So what we do, beta, we extend these rays backward. Now these are growing apart, like they'll continue to grow apart. Right, so we meet them in their virtual life. Now these are the real rays. They are going away. We extend these ray backwards so that it appears when I'm looking here. For me, it is coming from one single point, right? But where is that point? So we extend these backward. And wherever these rays meet, that is your image of this object. That is your image, beta, of this object. Understood? And this is your image. Now this was your object and this is your image. Now in this case, what will you write about image? Ma'am, that is a duvidha. That is a headache. So beta, you will simply write that image is formed behind the mirror. It will form behind the mirror. Okay, done. And now you tell me, are the real rays forming the image? Are the real rays forming the image? No, they are not. What are these? This is a virtual word. So what are these? These are virtual rays. The image will be virtual. Image will be virtual. And you see, from this top of this arrow, these rays are meeting on this head. So it is an erect image. It is not inverted like these. Like this, it is not inverted. It is not inverted. It is an straight image, right? Straight heads up image. So that is called your erect image. So what did we learn? We have 6 cases of concave mirror, right? In the first 5 cases, all the images are inverted. All the images are real. There we have different sizes of image. Small, same size, greater size, right? But in the 6th case, that is your stupid case, we don't have the real image. We have a virtual image. Okay, image is not formed on the left side of the mirror. It is formed on the right side of the mirror. Right? It is formed on the right side of the mirror. And this image is hence formed behind the mirror. In all these 5 cases, we have inverted image. In all these first case, this 6th case, we have erect image. We have erect image. Done? Understood? Okay. Till here, beta, we are done with our concave mirror. These are the 6 cases of concave mirror. In the first, we have object at infinity. We have, now clearly see carefully, okay? The object is at infinity. The object is beyond C. It is beyond C. It is, now see, at C. Right? The object is coming closer to the mirror. The object is between C and F. Okay? The object is at focus. It is at focus. The object is, okay, focus is somewhere here. This is not your focus. Okay. So, object beta is between, give me a second. The object is between focus and pole, right? You can clearly see that it is between focus and pole, right? Hey, I erased it. Okay. Now, beta, if you look at the images clearly, okay? Now, as the object is coming closer, the image is going away. The object is coming closer, the image is going away. First, the image was at focus. Then the image came on the opposite side of the mirror. It came between C and F, right? It was at F, it got away from the mirror between C and F, then more away at C, right? Then more away, that is beyond C, and in this whole case the object is coming closer, image is moving away. Now the image went to infinity. Image is like tata bye bye. Okay, and in the sixth stupid case we have image behind the mirror. Okay, this is behind. Done. So what is happening? The object beta, it is coming closer to the mirror. It is coming closer to the mirror, right? And the image on the other hand beta, the image, it is moving away from the mirror. This is moving away from the mirror. And as this image is moving away from the mirror, you will also see one thing, that here it is point size, here it is a little bigger, here it is equal to the size of object, here is larger than the size of object, here at infinity it is extra large, right? So for first 5 cases, as the image is moving away from the mirror, the size of the image, it is doing what? It is beta increasing. It is increasing. Understood? Clear? Right? Now in first 5 cases we know that images are real and inverted, but in 6th case beta we know that the image is virtual and erect. That is your one stupid case. So this whole is the image formation and the small things about your concave mirror. Now okay, sign conventions I'll tell you a little bit later. Just wait for this convex mirror to get it over with. Okay, now beta, just like concave mirror, we also have image formation by convex mirror, ma'am. Again 6 cases we have to study. Actually no, you just have 2 cases in your convex mirror. Okay, but rules are same. The ray that is coming parallel, it is going to pass from focus, but something very weird happened. Now this is not your convex mirror, this is your convex mirror. Okay, the rays are coming, now they are not converging, they are going away from the mirror. It comes, they go away, it comes, they go away. Now what we do? The thing we did in the 6th case of concave mirror. In the 6th case of concave mirror, we extended them backwards, right? So what we do, these rays are actually, they are coming and they are going away, right? They are not converging. So we extend them backwards, and we extend them, we saw if the ray is coming parallel and it is going away, if we extend it backwards, it looks like it is passing from focus. Principal focus, right? Then again, if it is coming towards the focus, it will reflect back and become parallel to the principal axis. If it is coming towards center of curvature, it will reflect back and move through the same path. We extended it backwards, we saw it is coming from center of curvature. Then beta, we have again this acting incident at pole, incident angle is equal to the reflected angle. Done. Now we just have 2 cases of convex mirror. First is literally at infinity. First we'll study this. At infinity, so what is happening? All the rays, these are coming parallel. All the rays are coming parallel, right? But they won't go like this. They won't go like this. They will go like this. They will go like this. Then what we will do? We will extend them backwards, and since they are parallel, so they are coming from focus. They are coming from focus. Now let's write about the image. Ma'am, this image is being formed at focus. Okay, now are the real rays meeting? They are not meeting. The image is formed by virtual rays, so this image is beta virtual and it will be erect, right? And it is point sized. It is point sized. Understood? Next beta, the second case, that is your normal case. Now in remember in concave mirror we have so many cases, beyond C, at C, between C and F. In this we don't. Convex mirror is like, I don't take all these pangas. Any point, at any point, if you place the object at any point between infinity to even pole, this is your pole till infinity. If you place it, the object anywhere between these points, what will happen? A ray will come parallel. It will reflect away from the mirror. If we extend it backwards, we see it is coming from focus. A ray is going and it is getting reflected back. If we extend it backwards, we see it is passing from center of curvature. Where these two virtual rays are meeting, an object, an image will be formed, and that bacha is your image formation by convex mirror. And in this case, your image will be formed between pole and focus. Between pole and focus. So image will be between pole and focus. First point, the image clearly very small. This is very large, very small. So the image will be diminished. It will be diminished. And ma'am, virtual rays are meeting, we know. So this is virtual and erect. Done. Image formation by mirror is done. Let's quickly see their formation. First, before that, we will see this. Yes. Now, beta, see what happened. We saw two things. In concave mirror, we had two cases. You have to make sure that you read this slide with your full mind and capacity. Okay. Now, we have two cases in concave mirror. First 5 cases, 1 to 5 cases, and a 6th case, right? Now this is our stupid case. Okay. Now beta, first to 5 cases, we saw what? We saw that the image is real and inverted. It is of all sizes. As the object is coming closer, the image is going away, and the size of the image is increasing from point size to diminished to same size to enlarged to extra large. Okay, so this is your basically the nature of image. Okay, in the 6th case, beta, what happened? In the 6th case, the image was not real and inverted, it was virtual and erect, right? And it was enlarged. It was enlarged, right? Done. In convex case mirror beta, we have just 2 cases, right? We have 2 cases. In both the cases, the image was virtual and erect, and it was diminished. In one case, it was point sized. In other case, it was diminished. So in general, we take it as diminished. Okay, I wrote I here. It will be a E, virtual and erect. Done. Now, plus this, we have to study these sign conventions. What are these sign conventions? Now, beta, I told you that this side of the mirror is called left hand side. This side of the mirror is called right hand side, right? Now, beta, do you know, understand x-axis? This is the negative x-axis, positive x-axis. This is positive y-axis, negative y-axis. Right? Similarly, just we curved these axes. Let's understand that. Okay, that means all the distances on the left hand side, of the mirror, they will be taken as negative. So we always took u. If you see, we always took object on the left hand side of the mirror. Left hand side of the mirror. This object, okay, look at the object. We always took the object on the left hand side of the mirror, right? That means the object distance will always, be on the left hand side of the mirror, and since it is on the left hand side, it will always be negative. So u will always have a negative sign. U is your object distance. Let's say my object is here and I say it is 10 meter from this mirror. So this u will be what? It will be minus 10 meters. It will be minus 10 meters. Understood? Then beta, in concave mirror, we know all the images were real and inverted, and all those images were also formed on the left hand side. You see, we started from here, all the images were on the left hand side, focus left hand side, images left hand side, then our image this image left hand side, image left hand side, our image, this is on infinity but left hand side, this is not real and inverted, we won't look at it. Okay, so all the images, they were formed also on the left hand side, they were real and inverted. So V, the image distance, is also negative for first to 5 cases. For first to 5 cases, the image distance is also negative. Done? See carefully. The image distance is also for real and inverted, it is negative. Now on the 6th case, it was formed on this side. That is your right hand side. Right hand side is what? Positive. So it was virtual and direct. Remember? So for virtual and direct, the image distance was positive. It was positive. Done? Understood? And your object distance always on the left hand side, always negative. Done? Understood? Now one thing you have to engrave in your mind, body, soul for concave mirror. Even when you talk about lenses also, but let's say whenever you hear a word concave, the first thing you have to remember, focal length, negative. Concave, focal length, negative. I will tell you a trick to remember this focal length just in a second. So beta, for concave mirror, this focal length is negative. This will be your negative because see, focal length is on this side, right? Focal length, when you were studying, see focal length on left hand side, focus left hand side, focus left hand side, left hand side. So focus or focal length beta will also be negative. Focal length will be negative and focal length is in the direction of radius of curvature. So radius of curvature is also beta, it will also be negative. Done? One more thing, if this principal axis, see, this is the axis, above we have positive, below we have negative. Now if we see that in all the cases of mirror, all these objects were above the principal axis. This is above the principal axis, right? This is above the principal axis, above the principal axis, above the principal axis, above the principal axis, above the principal axis. So all the objects, they have above the principal axis, right? They are above the principal axis. So that means their height is upward side of the principal axis. So on the upward side, we have positive principal axis, positive side. So height above the principal axis will be positive, and similarly the height below the principal axis will be negative. All these things you have to remember. Ma'am, how will I remember all these things? Practice. Okay? We will practice, you will practice with me, you will come into the live sessions, we will do the numericals, we will remember the sign conventions. So do not worry. Okay, done. Next beta, we have a very important thing, that is your same sign conventions for convex mirror. Now you tell me, in convex mirror, ma'am, I remember the focus is on this side. That is your right hand side. Right hand side is the positive side. Left hand side is the negative side. U is still on the negative side. U will always be negative for no matter what optical instrument. U is always negative. Done? Now beta, image is what? Virtual and direct. For virtual and direct, it is on the right hand side. We know we extended the rays backwards. So image is on the right hand side. So V, in the case of convex mirror, V is positive. That means for virtual and direct. Similarly, the concave mirror case, the 6th one, the image was on this side. For there, virtual and direct. Right? So the image distance will be positive for virtual and direct, negative for real and inverted for a mirror. Okay, so here the image distance will be positive. That is your virtual and erect nature of image. Done? Next beta, we have focal length. It is on right hand side. So focal length is simply positive, right? Radius of curvature, again positive. Height above the principal axis, positive. Below the principal axis, negative. Done? Understood? From this beta, we are done with mirrors, and let's just add on to it. See, in the first 5 cases, okay, this is real and inverted, and for concave mirror, we know the focal length is positive. Oh, my bad, focal length is negative. In the case of concave mirror, the focal length is negative. How do you remember this? Beta, you have seen this convex mirror, right? We have a x. If you rotate this x, it will be positive. It will be a positive sign. So that means the focal length of convex mirror will always be positive, and the concave mirror is just the opposite of what a convex mirror is. That means that will be negative. So x from convex means positive focal length, and then concave mirror will have negative focal length. That is the one thing you have to remember. Right? Now in these 5 cases, my V, the image was formed on left hand side, so it will have negative distance. Here the image was formed on right hand side, so it will have positive sign. Okay, in this case the virtual and direct image was again on right hand side, so it will have positive sign with the distance. U beta, U object distance is always negative. U is always negative. Your U is always negative because it is always placed on the left hand side. Always placed on the left hand side. Now I can guarantee you that this is the only slide you need to do any kind of numerical in your whole class 10th. This is the only slide you need. Okay, done? Okay beta, let's move on to the very next thing. Okay, before that let's go through the uses of spherical mirrors. They will ask you a question like, okay, tell me the focal length of a mirror used in a barber shop. Then you should know which mirror is used in the barber shop, right? So that's why uses are important. See beta, concave mirror makes an enlarged image. It makes enlarged image, right? Convex mirror always forms a diminished image. We saw that both the cases it is forming a diminished image. Okay, so where do we need large image? When we are doing makeup, when we are doing shaving, we need the area to look a little bit large so that we can easily see it, right? So shaving and makeup mirrors should be enlarged, right? Headlights of vehicles, so they can go light at wider places. You know, the focus, when we place the object at focus, the light goes at till infinity. We need that in our headlights, right? Then we have solar furnaces temperature. Now concave mirror is converging mirror. We want to gather all the light from sun and focus it on a point so that it cooks our food, right? So that is your solar furnace. Then dental mirror, again we need enlarged image and telescopes to gather the light from far away star and to focus it on the focus, principal focus, right? Then beta we have convex mirror, side view mirrors. On our vehicles, on our cars, we have side view mirrors. Now this convex mirror, it diminishes the image. That means a big truck can fit into the small mirror, right? But concave mirror also forms a smaller image, but it also forms an inverted image. We don't want to look at an ulta truck, right? We want to look at a straight truck. So this will give you a small but a bigger truck, image of bigger truck coming behind you, and that's exactly what you want when you are driving, right? Then security and surveillance, and this has so many applications: road safety mirrors, parking areas, peepholes in doors. So all are these the examples of concave mirror and convex mirror. Now beta, after that a very important formula, that is your mirror formula. You are given the object distance and they are asking you, this is the focal length of the mirror, let me know where the image is formed. Then beta, this mirror formula will be used. It is simply 1 by f equals to 1 by u plus 1 by v, and where f is simply the focal length. Now focal length was positive for convex mirror, negative for concave mirror. U is your object distance, right? Object was always negative, remember? And V is your image distance. Distance was negative for real and inverted. It was positive for virtual and erect. Done? Then simply beta this is the same thing. Now we have one more thing, that is your magnification. We saw that sometimes image is large, sometimes image is small, sometimes image is point size, sometimes image is at infinity so big. So how will we know which image is small, which image is big, how much big the image is, how much small the image is? That is where beta magnification comes in. Magnification means how much larger or smaller your image is as compared to the object. So we have this magnification formula, a little bit tricky to remember, but simply magnification is minus image distance divided by object distance, or height of image divided by height of object. We know height of object was above the principal axis, always positive. If height of the image is below the principal axis for real and inverted images, then it will be negative. For virtual and erect, we saw it was above the principal axis, right? So for that it will be positive. Done? Now beta, for that we simply have one exercise I had for you. Yes. Now beta, if this magnification is positive, if you remember these things, you will be unbeatable in your light chapter, in your numericals. Okay. Just remember, if it is greater than 1, then magnification is greater than 1. If see, magnification greater than 1, that means height of image by height of object is greater than 1. If I take this here, that means height of image is greater than height of object. Height of image is greater than height of object. Image has a bigger in size than object, so magnification is greater than 1. It is bigger, so magnification is greater than 1, right? Magnified image. Magnification less than 1, height of image is less than height of object, image is smaller, so image is diminished. Then we have positive. See, if you want to understand, then this is the thing for you. Magnification is minus V by U. Okay. Now U beta is always negative. If I put in the values, U will always be negative. Right? Now it depends on V. If V is virtual and erect, that means it is formed on the right hand side, that means V is positive. So this negative cancels out. Right? So if magnification is positive, that means the image is virtual and erect. But if this V is real and inverted, if it is real and inverted, then V is on left hand side. For left hand side, V is negative. Then what happens? If V is negative, then minus of minus V by minus U. This cancels, this remains minus value. So if there is a negative value, that means it's a real and inverted image. That means, if don't remember this, if you don't want to, this was just an extra information. It simply means that if magnification is positive, you have virtual and erect image. If magnification is negative, you have real and inverted image. Okay. So if it is plus 1 or minus 1, it is of same size, right? If it is 0, that it means point sized. So let's do this activity. Let's do this small activity. Magnification is plus 2. That means what beta? This from plus, ma'am, I will say that it is virtual and erect. Right? It is magnification is greater than 1. That means it is a magnified image. Understood? Then beta minus 2, ma'am, it has a negative sign. That means it is a real and inverted image. But still it is greater than 1. That means it is still a magnified image, but this image is real and inverted, this image is virtual and erect. Now beta, this is minus half. So it is negative, that means real and inverted, but ma'am, this is less than 1. Less than 1 means the image is diminished. Image is diminished. Now you tell me in the comment section. In the comment section, what will be m equals to plus half? Will it be magnified or will it be diminished? Will it be virtual or will it be erect? Or real, sorry. Done? Now beta, let's quickly see some numericals. I promised you that we will see numericals after every section. Okay, so mirror section is complete and ray diagrams of mirrors, concave mirror, convex mirror, their sign conventions, everything is complete. Let's quickly see some numericals. Those are very, very, very important. Okay, now beta, you have to pay attention clearly on how do we solve these numericals. Okay, solving numericals is one thing, completing completing the calculation is a very big part where students lag because they don't give proper attention to these parts. Okay, now beta quickly see, let's see the numericals. Now what you have to do beta, you have to first write what is given in the question. Now in my class we have this very important rule, we write as we read. Okay, we write as we read. So let's read quickly what is given and with that we will write it down. Okay, now a convex mirror, as soon as you see a convex mirror is given, you just write it down that beta a convex mirror is given. Now what is the focal length of that convex mirror? You don't know till now, but you know the sign of focal length we just studied, that is positive. So your focal length beta is positive for convex mirror. How did we remember? The x turn upside down and turn a little here and it will look like a plus sign, and hence focal length is positive. Okay, now it is used for a rear view, okay, on an automobile which has radius of curvature of 3 meters. So beta, radius of curvature is given as 3 meters. Understood? Then if a bus is located at 5 meters from this mirror, if a bus is located at 5 meters from this mirror, now beta, you tell me this bus is an object or an image. For now the bus is located, right? So bus is an object, so for object we use u, and that is your 5 meters. Now we also saw that u is always negative. Correct? U is always negative. So we have minus 5 meter from this mirror. Now we have to find. What do we have to find? See, we are writing everything in a perfect manner and you are studying how to present in the paper as well, in your PTs as well. Okay, so do not forget. Now, what do we have to find? We have to find position, nature and size of the image. We have to find beta position and we have to find the size. We have to find the size and nature of image. Very easy. Okay, let's see if you think it's easy now or not. Now we'll move on to the solution. Now beta, talking about solution, what is the first thing? How do you approach this question? Okay ma'am, we have to find the position. Now position is what? Position is your V. Okay, it is depicted by V. Okay ma'am, now I know the mirror formula. This is a mirror. I know the mirror formula we just studied. That is your 1 by F equals to 1 by V plus 1 by U. Ma'am, I have U. Okay, I want to find V. I have F. I don't have F, but I do have radius. So that means, ma'am, I know radius is half of my focal length is half of the radius, right? So radius is given as what? 3. So radius is 3. Focal length will be 3 by 2. Understood? And it's a convex mirror, so it will be a positive focal length. Done? Understood? Then beta, moving on, wait a second. Okay, no worries. Now beta, next we have to find V. Now moving back to mirror formula, we have F, we have U, we can easily find V. Okay, so beta, we have 1 by F equals to 1 by V plus 1 by U. 1 by F is what? See, F is 3 by 2. So 1 by F will simply be 1 by F beta. You will reciprocate this whole thing. This is F by 1, right? You reciprocate this whole thing. This will become 1 by F and this will become 2 by 3. So 1 by F becomes what? It will become 2 by 3. Understood? We want to find V and we have U. What was the U? It is given minus 5. Not just 5, minus 5 meters. It is minus 5 meters. Understood? So beta, this will simply be 1 by V minus 1 by 5 equals to 2 by 3. If this is minus, take this here, 2 by 3 plus 1 by 5 equals to 1 by V. Just solve this. 3 into 5, LCM will be simply 15. 3 into 5 is 15. 5 into 2 is 10 plus 5 into 3, 3 into 1. 3 equals to 1 by V. Then 1 by V beta will simply be 13 divided by 15. But now remember, this is 1 by V. Okay, this is 1 by V. We have to find V. So again we will reciprocate this and this will come out to be beta 15 by 13 meters. 15 by 13 meters. Now you can obviously solve this, right? It will be something around 1.67 or something like that, 1.01 or something like that. You see the calculation, okay? But you can also like leave it here. It will not be of any mistake. Just remember the sign. This is minus, it comes here positive, so V is positive. Now ma'am, how do we think if our answer is correct, if I have to check? So beta, look at this. We are given convex mirror. So this is your convex mirror. Now beta, we know in convex mirror, image is formed on this side, right hand side of the mirror, right? Right hand side is always positive. So V is positive. That means our answer is correct. Done. So we are done with the first part, that is position. Now beta, size. We want to see the size of this bus, nature and size of the image. Yes. So beta, see, in this case we are not given the size of object, right? See, whenever you want to find size, we saw the magnification formula. Now beta, magnification formula for mirror is simply minus V by U, or height of image divided by height of object. Understood? Now we want to find, they've asked us to find the size of image, that is height of image. That can only be found out if height of object is given. My height of bus is given, which is not given. So in this case you have to use little brain of yours and you have to see, okay, if the size of object is not given, we'll probably just have to give the answer till magnification. Okay, so we just have to find the magnification. How will we find? Ma'am, there is one more formula, that is minus V by U. So minus V, we just found out, that is your 15 by 13. See, here is where it gets used, the fraction. If you have already converted in the decimal form, it will be very easy now to divide it with 5. Okay, so you will do minus plus 15 divided by 13 divided by U. U was minus 5. So this minus minus cancels out. This will be 15 divided by 5 into 13 and this will be beta 3. So magnification comes as 3 divided by 13. Understood? So this was your whole answer. Okay, so magnification is equal to 3 by 13. You can convert it into decimal or you can leave it here as well. Okay, there is literally no problem. Now you can say that my image of bus will be 3 by 13 times the object or the actual bus. Okay, understood? So this will be your final answer for size of image or size of the bus, image of the bus. Okay, then beta, we have another answer question, that is nature. Now beta, this is convex mirror. For convex, we always forms virtual and erect image. Understood? Done. If you have any doubt, you can let me know in the comment section. These kind of numericals are very important in your tests, in your PT1, PT2, half yearly and boards as well. So mind you, never miss these kind of numericals. Okay, now these are important, you know how to solve them, but you have to understand how we go through it step by step, how we reach the calculation, where to leave the calculation, where to actually do the decimal to it. Okay, so make sure you remember all of that. Okay, okay beta, next we have a very important numerical again. Okay, an object 4 centimeter in size. What do we do? As we read the question, we write it down. So given is an object 4 centimeter in size. So height of object is given as 4 centimeter. Done. Is placed at 25 centimeter. So object is placed at 25 centimeter. That means U is minus 25 because distance of object is always negative, right? In front of a concave mirror. Now we are given with concave mirror. We are given with beta concave mirror of focal length. Now, as before you even go further reading this numerical, you have to write the sign of focal length, that is negative. Okay, sign of focal length, very important, that is your negative sign. Understood? Now beta, it has focal length of length 15 centimeters. So focal length is minus 15 centimeters. So because we know concave mirror has focal length negative. Okay, wait a second. Yeah, so we wrote that now focal length is minus 15 centimeter. At what distance and nature and what distance from the mirror should a screen be placed? Now beta, what is made on the screen? Ma'am, image. So we have to find image distance, correct? So beta, here to find, what we have to find? We actually have to find the image distance. At what distance the mirror should be, the mirror should be a screen be placed in order to obtain a sharp image. Find the nature and size of the image, and similarly in this also you have to find the nature, you have to find the nature and size of the image. Again, can you do it? Pause the video and try to do it by yourself and then see the solution. I'm doing it here. Okay, okay, done. Okay, great. Let's move to the solution. Now beta, while solving this, again how you have to think is the main part here. Okay, ma'am, I am given with focal length, I am given with u, I have to find v. Very basic, very easy. I'll just use the mirror formula. Okay, let's use the mirror formula. 1 by f equals to 1 by v plus 1 by u. Understood? Simply put the values. U is given as minus 25. U beta 1 by F equals to 1 by V plus 1 by U. Now U is given to you as minus 25 centimeter. V we have to find, and F is minus 15 centimeter. 1 by minus 15. Remember to always write it in the denominator. This is a silly mistake that people might make, the children might make. Okay, now beta, this is minus, you simply keep it here, it will be a plus, right? So okay, let's do it properly. 1 by V minus 1 by 25. Understood? 1 by 25 equals to minus 1 by 15. Now this minus 25 comes here. Minus 1 by 15 plus 1 by 25 equals to 1 by V. And you take as LCM. Now what is the LCM of 15 and 25? That's where your calculative mind comes in play. Okay, that will be 75. 15 into 5 will be 75. Minus 1 into 5 will be minus 5 plus 25 into 3, 3 into 1, 1. 3 into 1, 3. Okay, 1 by V. Done. Now you just solve this. We have minus 2 divided by 75 equals to 1 by V. Now we reciprocate it. So V will be minus 75 divided by 2. That will be beta 37.5. So V comes out to be minus 37.5 centimeter. Neither you will forget negative nor you will forget a centimeter. Both of these can cost you extreme marks. Okay, good. Okay, now we found V. We want to find the nature and size. See beta, concave mirror, if you want to use a little bit of brain, okay, it's a concave mirror. Okay ma'am, in concave mirror we have 6 cases. 5 cases are normal one and 1 case is a stupid case. In these 5 cases my image is real and inverted. In this 1 case my image is virtual and erect. Now this case is formed when U is less than focal length, when my object is placed between focal length and pole, focus and pole, right? Then only the image is made as virtual and erect. Now beta, that means U is less than focal length for 6th case. Now is the U less than focal length here? U is 25, focal length is 15. So U is more than focal length, right? Object is not between focus and pole, it is somewhere behind. So that is this 5th case. That means the nature will simply be beta real and inverted. Understood? How I used my brain. Understood? Done. Okay. Next, coming to size. Now beta, understand, we talked about in the last numerical that height of object is not given, but here the height of object is given. But still, how will you find magnification, ma'am, is height of image by height of object. Now height of object is given to me, it is 4 centimeter in size. Okay, that is 4 centimeter, and height of image I have to find, but I still don't have magnification. So what will I do? I will use another formula of magnification, that is minus v by u. What is minus v by u? Now beta, you can use minus 37.5, but is it easier to calculate? No. 75 by 2 is easier to calculate. So v was what? V was also 75 by 2, minus 75 by 2. Okay, so I can use that value as well. Done. So what will happen? Here I have minus of minus 75 by 2. There are two minuses. Make sure you are using both these, because if in any case your magnification is not negative but is supposed to be negative, the answer will be wrong. Okay. Okay, now u was simply what? U was minus 25. It was minus 25. Understood? So magnification beta, it comes out to be height of image divided by 4 equals to, now see, this minus and this minus cancels out, and we have minus 75 divided by 2 into 25. This 2 will come in the denominator along with the 25. Okay, and you cancel it. 22, 25, 3s are 75. So this will be height of image beta. It is minus 3 into 4 divided by 2, which is 2, and height of image comes out to be minus 6 centimeter. Understood? Understood? Any doubt? I think the whole numerical is clear, right? Okay, very good. Let's move on to the next numerical beta. A concave mirror produces 3 times magnified image. What is given? We will write what is given. Now beta, given is a concave mirror. Okay, let's quickly write that concave mirror. Make sure you are writing mirror with it, because one time I confused mirror with the lens and did the whole numerical wrong. It was given the mirror, I did take the lens, so do not make that mistake. Now what is the sign of focal length? Ma'am, negative, since it's a concave mirror. It produces a 3 times magnified. So magnification beta is 3, but read it carefully. 3 times magnified and enlarged real image. Real image. And what we just studied, whenever magnification is negative, we have a real and inverted image. So in here, if there is a real image, magnification will be negative. That's how you correlate things. Done. Then beta, of an object placed at 10 centimeter in front of it. Now object beta is placed at 10 centimeter in front of it. Where is the image located? We just have to find where is the image located. To find V, right? That is what we have to find. Now this is very easy and you won't probably have to use so much of brain. Okay, what is the solution now? Now beta, solution is simply, I have magnification, I have u, I want to find v. I can use the very basic formula of magnification equals to minus v by u. Understood? Now beta, see, magnification is minus 3, right, equals to minus v, I have to find minus v, and u beta, u is minus 10 centimeter already given. U is minus 10 beta already given. Now can I cancel these two signs? These are in denominator, minus minus cancels out, v goes here, so v comes beta minus 3 into 10. Right? So V comes out to be minus 30 centimeters, and we have a very proper sign as well as centimeter, that is your units, along with your whole answer and answer in a box. Done? Okay, moving on, next numerical. A student wants to obtain an erect image. A student wants to obtain an erect image. Okay, erect image is our goal. Okay, of an object using a concave mirror. Now which mirror is given to us? We are given as concave mirror and its focal length is what? Sign of focal length is negative. Very good. Now of 10 centimeter focal length. Okay, now focal length is also given. Focal length is 10 centimeter and it will be negative. This is all beta what? This is your given part, right? Next we have what will be the distance of object from mirror. Ma'am, so the focal length is given. What about u? How will we find v? Now see, very important detail that you must have missed is this. An erect image formed by concave mirror. In which case concave mirror forms erect image? Okay ma'am, concave mirror has 6 cases, 5 cases and 1 stupid case. In these 5 cases it is real and inverted image. In the 6th case ma'am, it is virtual and erect image. We need erect image, right? We need erect image. Now beta, in which case? In this case, where is the object placed? Ma'am, object is placed between my focus and pole. Object is placed somewhere here. This is your object. So it is less than focal length. That means u is less than focal length. Understood? That means simply the answer will be that u will be less than your focal length, that is 10 centimeter. This will be beta your final answer. Okay. If they have given a specific u, okay, there will be a specific value of u, let's say 20 centimeter, not 20, it has to be less than 10. So let's say 5 centimeter and u is always negative. Then you will have to calculate through mirror formula. Right now they have not given, so you can simply say that this is your answer, u is less than 10 centimeter. Understood? Okay, let's moving on. We have a very important question. Just look at the years 2015, 2016, 2018, 2019. Oof. And from so many years it has not come. That does not mean it will not come. Exact this has not come, but questions like this have come. Okay, great. Now beta, what is given? A given is that if the image formed by a spherical mirror for all positions of object placed in front of us is always erect, it is always erect and it is always diminished. It is always diminished. Okay, what type of mirror is it? Do I even have to tell you the answer? You tell me in the comment section. Write down right now in the comment section what is this mirror. Okay, come on, fast. Draw a label diagram to support your answer. Okay, let's do that. Now beta, how will you make a diagram is very important. First of all, if you have time, use a protector. Use a protector to make a proper mirror so that you can have a definite circle of radius, okay, radius of curvature, circle of radius, radius of curvature, and then half of that will be your focal length, and then your diagram will be numerically correct, will be scalable. Okay, scalable, correct. Okay, and that's how you won't get any mistakes in numericals. But if you don't have time, then maybe just skip that step. Okay, this is your concave mirror. We need, okay, wait, it should be always erect and diminished. Okay, here we have some problem. Okay, I hope everyone have answered by now. So erect and diminished image is always produced by your convex mirror. So we will use a convex mirror. We will use a convex mirror. Now for convex mirror, obviously the focal length and radius of curvature will be on this side, but u is also always on the left hand side. So beta, we have a u, and what they are saying always erect and diminished. So simply you make two rays, one is passing through focus, one is diverging, but if you extend it back, it passes through focus. Another ray beta, it passes through center of curvature, and the point where these two meet is your image. This is your image, and this is erect and clearly diminished. Understood? Good question. And look at the number of times it has come. Now after this I will have 1 or 2 more questions of this mirror, and then we will move on to our lenses section. We'll understand the lenses first, then we'll do some numericals on lenses as well. Okay, there are not so much numericals that come on lenses part, but they do come. Okay, next beta we have a spherical mirror produces an image of magnification -1. Okay, so we have magnification as -1 and placed at a distance of 40 centimeter. So U is, wait, a spherical mirror produces an image. So this image is being produced at 40 centimeter away from the mirror. So this will be your V. V will be your -40 centimeter. Will it be minus? Will it be positive? Will it be negative? What will it be? You tell me. Okay, let's study the properly. Now, a spherical mirror produces an image of magnification -1. Now, beta, what do you understand from this? Ma'am, we understand that magnification is -1. So, image is real and inverted. Image is real and inverted. Which mirror always forms real and inverted image? That is your concave mirror. Concave mirror, ma'am, we know convex mirror never produces real and inverted image. You think, you know, you can see how to think, right? Okay, so now we know, even though it is not mentioned, we know it is a concave mirror. We know that it is a real and inverted image. And if it's a real and inverted image, if it's a concave mirror, then the size of the sign of the image will be what? This is your concave mirror, right? And on your left hand side, the image is being formed, which is real and inverted. So that is negative. So your V has a negative sign. That is the reason. Understood? Okay. So what type of mirror is this? See, when you do this question, you don't have to read the parts. You already know this is a concave mirror. I told you. Then beta, what is the nature of the image formed? Again, real and inverted. Then beta, how far is the object located from the mirror? Now this is the part which you have to solve. But we have magnification, we have image distance, simply minus V by U. Right? Minus V is minus of -40 divided by U. Magnification is given as -1. Right? So this minus cancels out. U beta comes out to be -40 centimeter. Oh, can you see? U is also -40 centimeter. V is also -40 centimeter. That's why magnification was -1. Can you clearly see magnification is -1? That means height of image is equal to height of object. Size of image is equal to size of object. That means it is the object is on radius of curvature. It is placed on radius of curvature because that's the only case when V and U are equal. Height of image is equal to the height of object. Then draw the ray diagram to show the image formation. In this case, we have already drawn the ray diagram, and this is how you draw the ray diagram. Before even reading all the parts, we were done with the question. Now imagine this speed in your boards or your PT tests. Okay. Next beta, let's see. It looks like a very big question, and see how many times it's been repeated. And you tell me if it was hard or not. If it was easy. It was easy, right? Okay. Next question beta. Okay, now we are entering into refractive index. Let's complete that topic first. Okay, let's complete refractive index and lenses first, then we'll move to its questions. Okay, what is this? What is this? Have you seen something like this? Something crazy like this? Right? So, ma'am, we have actually seen these phenomena. When I take a glass and I look through it, my siblings see a distorted face of me, something like this. When sometimes I go into the pool, it's just an extreme case actually. But do you see inside the pool, right? The person looks a little bit short, but their actual body is tall. They are tall, you know that. But they look a little bit short and a little bit distorted. So, what is happening? That beta is refraction. What is happening? Refraction, our second phenomena. First was reflection, light bouncing back and coming back to you. Then it's refraction. Now, what is happening when someone is in water? Light is coming from the water inside the air. That means it is traveling from water to air. It is changing its medium. What do you call it? Medium. Whenever light travels from glass to water. So glass has different medium, water has different medium, it has different properties, air has different properties, oil has different properties. So whenever this light switches between mediums, it goes from oil to water, it goes from glass to water, from water to air, from glass to air. Refraction happens. That means bending of light. Whenever it goes from water to air, it bends. It bends. Okay, and it bends away towards, we'll study about that, but let's see what basic refraction is. Okay, it is the phenomena of bending of light, when it passes from one medium to another, having, very important part, having different densities. Now beta, in air is a gas, molecules are very very far away, so its density is less. Density is mass upon volume. How many mass is there in a single volume? So in this area of gas, the particles will be lesser, but in this amount of water is a liquid, particles will be more tightly packed. We studied about that, right? Particles will be more tightly packed, correct? In air, they will be loosely packed, so they will away, they have so many space, so their density is different. Here the particles are less dense. Dense is how much? Ghana. In Hindi we say. So how many particles? More particles, more density. Less particles, less density. Water has more density, air has less density. So whenever light changes a medium which has different densities, it bends. Okay, so the bending of light when it changes a medium and having different densities, it is called refraction of light. And you have probably seen these things, right? You put a straw. Now what is happening? The light from this straw inside the water is coming outside the water, then going into our eyes, right? It is going from inside the water to the air, then going into our eyes. So it is changing the medium in between, and hence it is bending. Okay, it is bending. Now beta, this bending can be of two types. Now you tell me, okay, there can be two cases. You have this thing, okay, and inside beta you have lots of water. Okay, you have lots of water, and outside it's simply just air. Okay, now what is happening? This light is coming. Now there is something placed inside. Okay, so the light is coming from water into the air. Now we said that air, ma'am, air, and this is water. So air has less density. Now anything which has less density is called a rarer medium, and anything which has more density will be called a denser medium. It will be called a denser medium, and the which has low density will be called a rarer medium, right? Rarer medium, denser medium. Now beta, there are two things whenever light goes from, whenever we will give you two examples. Okay, now this is rarer medium, denser medium, rarer medium, denser medium. Okay, now let's do it ulta. This is denser medium, rarer medium. Okay, we have two cases. Now whenever beta the light is going from rarer to denser, here we have a normal, just like we had in reflection, we will also draw a normal. Now in refraction what had? Light went back. Okay, but in refraction, after hitting water, it won't go back into the glass, right? It will come out, right? So it will go on the other direction. So whenever, like technically it should go like this, straight, right? But it bends. Where should it bend? Now it's normal, right? This is normal. So when traveling from rarer to denser medium, the light will bend towards the normal. It will bend towards the normal. So beta, instead of going straight like this, it will bend towards the normal, and this incident ray with the normal incident angle. Now this is your refracted ray, not reflected ray. That was reflected ray in reflection. This is called refracted ray. So this is your refracted ray, and the angle with the normal is written as R, but is called angle of refraction. Done? Angle of refraction. Okay. Next beta, similar to this. Now this was rarer to denser, rarer to denser, rarer to denser. Now let's see, if light goes from air, the light is going inside water. You are under the pool, you are looking someone out, someone, right? So the light is coming from air into water, into your eyes. So it is going from denser to rarer. Now beta, when it goes from denser to rarer, it moves away from the normal. It moves away from normal, right? So these are the two things you have to remember. So what will happen? This light ray is coming, right? This light ray is coming. This is your normal. So this is incident ray. This is your incident angle. Technically it should go straight like this, but there is a change in the medium, so it will bend away from the normal. This is simple, but it will go like this. It will go like this. Now here it bends towards the normal, right? But on the other hand, it bent away from the normal, and the angle with the normal, this is the normal. So this whole angle beta, this is called angle of refraction, and this is your refracted ray. Understood? Both the cases clearly. Very good. Okay. Okay. Then beta, let's move on to understanding something, a conceptual question. Now what happens if you ever met a fisherman, okay, or have you ever seen them working? You know, they tell you that the fish looks like it is here, but actually it is not here. It is a little under it or above it or somewhere else, not at the position we look at it. Why? Because the light from the fish is coming into the water, then changing the medium into the air, and it is bending. When this light bends, this is your fish. Okay. Now, when this light is coming out, this is water. When this light is coming out, so instead of going straight, it bends and then it reaches our eye. Right? Now actually, if remember, we extended the rays back in our reflection, so our eyes do that automatically. It refracts, it traces back this ray, it extends back, and this ray feels like the fish is here. Actually the fish is here, rays are coming out, it is bending. That's why our eyes trace them back. That's why here this kid, the fish is actually here. This is the actual position. This is the actual position, but to him it looks like the rays bends and it looks like the fish is actually here. So to him the fish is actually here, but in reality the fish is here a little bit under. So the actual position of the fish is called actual position, but the position where we look at it, where to us it looks like the fish is there, that is called perceived location or apparent location. This is actual location where the fish is actually there, but apparent location is where it looks like the fish might be because of the refraction. Similarly, if you dip your half of the pencil inside this water and you see from a water glass, right, your pencil will look broken. Your pencil will look broken. Why? Because the rays from this point, this is an actual pencil, it comes out, right? And at the water, it's not going straight, it bends, and then we extend these rays backward and it looks like the pencil is here. Done. Similarly, we have a coin. It looks like the light is coming from this coin and it is getting bent. So it looks like the coin has risen above in the water. Done. These are some basic concepts. Okay, so they can ask you a question on this. That's why I'm trying to fit these into your brain. Okay, next beta we will have laws of refraction, just like we had laws of reflection. Now the second law, remember, the incident ray, the reflected ray and the incident all lie in the same plane. Now in here beta we have this diagram, something like this. Okay, rarer to denser and denser to rarer, rarer to denser, and this is your denser to rarer. Right now beta, the second diagram, the second law remains almost the same, that it says the incident ray, the refracted ray and the normal, the incident ray, the refracted ray and the normal all lies in the same plane, but in there the normal was normal at the points of incidence. Here beta, the definition of normal is a little bit different. Here the normal, we are drawing the normal on the surface of water. Now water, the first layer of water is something that separates water and air, right? So that is called interface. Two phases, air and water, and the layer that is separating them, again a layer of water, but it's the first layer of water and the first layer of air. So this is called interface. Okay, so normal to the interface of two transparent media at the point of incidence all lie in the same plane. Done. Until here it's clear. Now we studied that with this normal we have angle of incidence, with this refracted ray we have angle of refraction. Now in there we studied angle of incidence is equal to angle of reflection. In reflection, in refraction beta, it is something different. What is that? It is this particular relation, that sine of angle of incidence. This angle of incidence, sine of this angle of incidence divided by sine of this angle of refraction is equal to constant. It is equal to constant. The ratio of angle of incidence to the sine of angle of refraction is a constant for the light of a given color and for the given pair of media. So for water and air this will be constant, but for water and glass this will be different, but for constant for them all along throughout the beach, this ratio will remain same. Throughout there is a big glass, at this point where the ray is getting in and at this point where the ray is getting in, it's the same value. But for glass and air it is different, for glass and water it is different, for air and water it is different. Done? So for a given pair of media it will be constant. This bacha is also known as, very important, Snell's law of refraction. It is also known as Snell's law of refraction. Understood? These are the two laws that you have to remember. Done? Next beta, let's dive deep into the refractive index. Let's do this first. Okay, then we'll talk about refractive index. Very interesting concept. Now see beta, we have this was absolute refractive. Yes, this. Okay, so beta, there's something called glass slab. Okay, you will have a glass slab in your labs as well. What you do, it's like a block of glass. It's like a big block of glass. It will look something like this. Okay, but it is made up of glass. It is made up of completely glass. Now what we'll do, we'll throw some laser lights into that glass, and of course now light is going from air into the glass, then also it will come out from glass as well. So it is going from air into the glass, then glass into the air as well. Done? So let's see what happens. Now beta, see, this air, this incident light is going from air, hitting that glass interface, right? And from this, of course, air is rarer and glass is denser. That is the most basic thing you should know, right? Then it will bend towards the normal or away from the normal. From rarer to denser, ma'am, this bends towards the normal. So it will not go straight, it will bend towards the normal. So this is your incident angle, this is your refracted angle. Okay ma'am, but this also comes out. Now it is coming out from glass into the air. From glass into the air. So it is going from denser to rarer medium. Now ma'am, from denser to rarer medium, the rays bends away from the normal. So instead of going straight like this, it bent away from the normal, and this beta now is called your emergent angle, because this ray is emerging out of the glass slab, right? So it will be called emergent angle, and this ray will be called emergence ray. Okay, this will be called angle of emergence, and that will be your emergent ray. Right? Now a very interesting thing you will notice from here. You will notice that when you see, let's say you're looking at from here. So technically this incident ray shouldn't have bent in an ideal condition. Okay, if there is no glass slab, this will go straight like this, right? So this is going straight like this, okay? And if you place a glass slab, this will go something like this. Instead of this, this is coming out from here, right? But you will see that this emergence, this emergent ray and this incident ray, the incident ray which was not hurdled by the glass slab, if this glass slab was not there, it will go like this, right? So these two rays are parallel. This incident ray is parallel to emergent ray, a very important point. And beta, this incident angle is equal to this emergent angle. Incident angle equal to emergent angle. These two results are the problem why this thing is very, very important. Now you understand that, right? These two results look even quite important, right? So now actually the ray should go like this, but it just got displaced and goes like this. It's parallel. It just, instead of coming out here from here, it is coming out from this point. So this displacement that happened between this incident ray and emergent ray, this is called lateral displacement. That instead of going like this, the ray just came out from this. So this displacement is called lateral displacement. Now we have I as angle of incidence, R as angle of refraction, E as angle of emergence, and this this distance from which it got displaced is called lateral displacement. Understood? Next beta, we have a very important point, that is your absolute refractive index and refractive index. Okay, now refractive index beta, we talked about air and water. They have different densities and the bending of light is different, right? From air to water, bending will be different at different angle. From air to glass, the bending will be at different angle because their densities are different and hence their refractive indexes are different. What do you mean by that? The extent of bending, how much the light is bending while going from air to glass, air to water, glass to water, water to glass. The extent of bending of this light, the extent of the change in direction of the ray of light that takes place in a given pair of media beta is expressed in terms of refractive index. Okay, and this is directly proportional to speed. Ma'am, how? You try to run in air and then you try to run in water. Will you be able to run with the same speed? No. Similarly, light is also not able to travel with same speed in water or air. So this refractive index depends on velocity of the light inside that medium. If it is traveling easily, then it's a rarer medium. If it is facing difficulty, then it's a rarer medium, right? So if refractive index is more, velocity of the light will be less. If the refractive index of the medium is less, that means it's a rarer medium. That means velocity is more, it will be easily run through that medium, right? So it is inversely proportional. Now how do you write this? Beta, you write it like this, N21. That means refractive index of medium 2 with respect to refractive index of medium 1. Let's say refractive index of water with air. That means light is going from air into the water. That means refractive index of water inside and with respect to refractive index of air. And this means light is traveling from air into the water. It is going from first medium to the second medium. That is what it means. Okay. Now, I told you velocity is inversely proportional. That means if the velocity of light in air will be more than velocity of light in water, right? Velocity of light in air will be more than velocity of light in water, but we know water is denser, so refractive index of water will be more than refractive index of air. So aren't these inversely proportional? Aren't these inversely proportional? So that means beta, in here when we write the formula, we will write V1 by V2. We will write V of A divided by V of water. Understood? Understood? Okay. Next beta, like this is the whole formula and thing for refractive index. So the extent of change of direction of light is called your refractive index. Now we talked about refractive index with respect to a medium, refractive index of water with respect to air, of glass with respect to air, of glass with respect to water. Okay, so all these are refractive index. But beta, if we talk about refractive index of water with just air or vacuum, mostly vacuum, but we take at your level air only. So if we talk about refractive index of water with respect to air, refractive index of glass with respect to air, refractive index of kerosene oil with respect to air. So all these beta are absolute refractive indexes. Absolute refractive indexes. That means, let's say you have a refractive index of glass with respect to water. That means light is going from water into glass. It is already having less speed in water. In glass, it will have more less speed. But if in air, where there is no hindrance to the light, to the velocity of light, it is easier to calculate the exact refractive index of glass with water or air. Obviously, ma'am, with air, right? So these are called absolute refractive indexes. Understood, beta? Okay, these are mostly the basics of your refraction, basics of the optical instrument that we are going to study next. That is beta your lenses. Now again, we have two kinds of lenses, just like your mirrors. We have concave lens and beta we have convex lens. Now we know that these are reverse of your mirrors. That means all the properties of concave mirror are now having with convex lenses. That means concave mirror has 6 cases. Now convex lens will have 6 cases. Same, it has 5 good cases and 6th case will be your stupid one. And convex mirror had 2 cases. Here concave lens will just have 2 cases. Done. Here also you can remember through the cave formula, right? So here also the light is going inside the cave, but now cave is on the both sides. So convex lens is the other shape, right? If you have to write what is concave lens, how does it look like? It is thinner at the edges, thinner in the middle, thicker at the edges, thicker in the middle, thinner in the edges. Right? Now we have to study about the image formation in lenses. Okay, so what is the terminology? Just like we studied center of curvature, radius of curvature, here it is a little bit different. Okay, let's see. So this is your what? Thicker at the edges, thinner in the middle. This is your concave lens. This is your concave lens going in the cave, So beta, see, there we only had one sphere. We had just this, we completed the sphere. But if I complete the sphere here, there is one sphere here and one sphere here. One sphere here. So I will have 2 center of curvatures, 2 focal lengths. One on this side, one on the other side. So on the left hand side, the focuses are called F1. On right hand side, beta, it is called F2. And in here, we used to call it center of curvature, but in here we call it 2F1. It is similar, double of this F1, but 2F1. Okay, and in here it will be 2F2. Right? Here, beta, we had pole, but here we will have optical center. Optical center. Similar with convex lens. F1, F2, 2F1, this will be 2F2, this will be your optical center. Done? And similar, almost similar cases, the rays that is coming parallel is passing through focus. Okay, they are passing through focus, but we have to study it before actually drawing it. Okay, because both have the diagrams that we use to draw is a little bit different than mirrors. It's not exactly the same. Okay, so let's look into the convex mirrors first. The number of cases, all the nature of cases are same. Convex mirror is similar, convex lens is similar to concave mirror. That means it has 6 cases. And beta, now convex lens is our converging lens. It is your converging lens. Understood? Now beta, first case, all the rays, the object is at infinity. All the rays coming parallel, and now this is a converging lens. So all the rays will meet. All the rays will meet. Now even though it's mirror or lens, the focal length will remain positive. The focal length will remain positive. And also you see which focus is we are using. The right hand side focus, right? Right hand side, the directions are taken to be positive, right? So they all collectively and meet at your F2. So here when you write about your image, beta, you write that image is being formed at not just focus, it is formed at F2. Okay, now in concave mirror, what kind of image is formed? I mean, first 5 cases, real and inverted image was formed. Same case here, real and inverted image. But one thing you have to be very sure about. In concave mirror, remember, all the real inverted image were formed on left hand side. But in lenses, it is forming on the right hand side. That means here beta, the image distance is positive for real and inverted and not negative, just like in the case of concave mirror. Let me go and show you. Actually, this is very important. So when you look at all the sign conventions, where is it? Yes. So you see, real and inverted, negative, because for real and inverted all the image was formed on the left hand side. Real and inverted, negative. And you see here we have formed the real and inverted image, but it is on the right hand side, it is positive. Done? Now bring the object a little bit closer. Same to the concave mirror. Nothing different. Beyond 2F1. Now there it was beyond C, right? But here we use 2F1. So it is 2F1. Again, see, one ray goes parallel, and now beta, earlier, this is true. So it passes from focus. That is true. Now earlier we used to have this concept that if it rays goes from center of curvature in mirrors, it reflects back and traces the same path. In lenses, we have this concept that if a ray passes from optical center, it does not have any refraction. It does not get refracted. So a ray comes, goes, without refraction, goes the same. And similar here, see, the object, the object beta is beyond 2F1, beyond C. In that case, if it was beyond C, the image will be between C and F. Here C is, now here is 2, F2. Just you have to remember that. Here beta, the image will be between what? F2 and 2F2. Real rays are meeting, so it will be real and inverted. And similar to there, the image was a little bit smaller. So here also the image is smaller. So the image beta will be diminished. It will be diminished. Similar to concave mirror, exactly similar. Just it is forming on the different side, and instead of C, we are using 2F. And instead of simply C, we are using F2 and 2F2. Okay, now more closer, 2F1, the image will be where? 2F2. Now the object is at 2F1. The object is at 2F1. Do you tell me where the image will be? Ma'am, at 2F1, at 2F2. In the lens, it will cross the lens and the image will be at 2F2. F2. So the image beta will be at 2F2, again real and inverted, again same size, just like the concave mirror, same size. So what is happening? One ray is coming parallel, bending, passing through focus. Another ray going into the optical center, passing straight. Done. Then bring your object a little bit more closer, between 2F1 and F1, between 2F1 and F1. Okay, now what will happen? Ma'am, for between 2F1 and F1, the image will go beyond 2F2. The image will go beyond 2F2. So the image will be, see, this is very simple, right? That's why I'm putting a little low, I'm not drawing it all again, right? That's your homework. Okay, so because this is very easy, very easy, you just draw one line parallel, pass it through focus, another directly from optical center. You just place this F1, F2, 2F1, 2F2 at equal distances. That's your only work. Okay, now again, this is what? Real and inverted, and this is of bigger size, so this is enlarged. Understood. Now bring the object more closer. It will be at F1. So it is now at F1. It is now at F1. The object is at F1. The image will be, ma'am, not formed. The image will simply be not formed. Just like our concave mirror. Done. Next beta, more closer. So the image is, the object is between F1 and O. Now if you remember concave mirror, you must remember then the sixth case, the stupid case, the image was between focus and pole. The image was being formed on right hand side, on this side, instead of all the 5 images which were formed on left hand side. It's just reverse in the case of lens. All the first 5 cases have images formed on right hand side, but in the 6th case, the stupid case, the image is on the left hand side. Why? One ray goes parallel, passes through focus, very good. Another ray passes through focal length. They are growing apart. They are growing apart from each other. So if I'm standing here, it will look like they're growing apart. It will look like they're coming from a point, right? So we extend them backwards, and this is the point they are coming from, and then this beta is your, this is your image. This is your image. So your image is beta behind the, yeah, or you can simply write the image is on the other side of lens, on the other side of lens. That is your beyond. Now beyond 2F1, 2F1, remember this 1, 2F1, okay? In all other cases, we used 2F2, okay? We used 2F2, F2, okay? F2, F2, but here the image is on the other side, so that means we will use 2F1. That's the only difference. Okay, done. We are done with 6 cases of convex lens, just like concave, mirror, and these are very simple. All the nature of images are same, just the sign of the V. Sign of V is different. It is positive for first 5 cases. It is negative for the 6th case. It is negative for the 6th case. That is all you have to understand. Okay, then beta we have next instrument, that is your concave lens. Concave lens is similar to convex mirror. Convex mirror had 2 cases. First was when at infinity, the object was at infinity, the image was being formed at focus. The only difference is the image was formed on the right hand side in the convex mirror, right? But in concave lens, it is formed on the left hand side. It will go, now this is a diverging mirror beta. It is a diverging mirror. That means it will throw the rays apart, not meet them, apart. Okay, so if I am standing here, it will look like they are coming from a point. I extend them backwards and they were coming from F1. So in this case, you will write that image is at F1. The image is at F1. Understood? The images can be a little bit confusing. If you just replay the video, you will understand. If you cannot, okay, but this is very simple. It is diverging, extend them backwards, meeting at f1. And similarly, in the case of convex mirror, we had a second case, place it at anywhere. Similar to that, we have, it is placed at, no, this is wrong, okay. So, the image is between beta here, your optical center and infinity. So from infinity till optical center, you place your object literally everywhere. It will give the same image. So one ray goes parallel. Now instead of converging, they are diverging. They are going away. You extend them backward, it passes through focus. Another ray goes through optical center. That is common. Okay, so this is the point where these two rays meet, and beta, this will be your image. Now this image is at a different scale. This image beta, it is formed between your f1 and optical center. This is your f1, this is your 2f1, this is your 2f1. So it is placed between f1 and your optical center. Done? Understood? Done and dusted. This was your whole refraction. Now let's quickly revise those. The sign conventions you have to remember, okay? Now here, this is your left hand side, this is your right hand side. All the distances in the right hand side is positive, all the distances in the left hand side is negative. U beta is always negative. We studied about it and will study again and again that U is always negative, right? Because it is always on this side. Now in lenses, we are seeing that the image is formed on the right hand side, but this is a concave lens. In concave lens, image is being formed on the left hand side. Image is being formed on the left hand side. Left hand side. So on the left hand side, we will be also negative. We will be also negative. So this beta, this gives a virtual and direct image. Concave lens, no, this was, yes, it was concave lens. Similar to convex mirror, it will give a virtual and erect image. It will give a virtual and erect image, and it is always diminished. It is always diminished. Virtual and erect image, and it is always diminished. You can see virtual and erect and diminished, right? Virtual rays are meeting. Then beta, this is virtual and erect, and it is forming on the left hand side, so it is negative inside. U is beta C, always negative. Height above the principal axis positive, below the principal axis negative. Focal length for concave lens, negative. Concave lens, concave mirror, always negative. Radius of curvature, always negative. Understood? Then beta, same for convex lens, we have left hand side, U is always negative. Now in this case, all the real inverted images were formed on the right hand side. So for right hand side, for real and inverted, the image distance will be negative. Okay, it will be negative. And for virtual and direct, the sixth case that was forming on that side, it will be negative on the left hand side. Everything else is same. Done. Now one thing that is left in your whole, this is your 2 or 3 formulas. That's it. First is, just like you studied mirror formula, you have lens formula, and the only difference you have in this lens formula beta is this. Is your, the formula is 1 by V minus 1 by U. In the mirror formula, you had 1 by V plus 1 by U, right? But in here beta, you will have 1 by V minus 1 by U. F is focal length, V is image distance, U is object distance. Negative sign, positive sign is all related to those sign conventions. If you are confused, you want practice, join the live sessions and we will do all the numericals there. Okay. Next beta, we have again magnification. Magnification we had simply, magnification was, in mirror formula we have minus V by U, right? But in lenses, in case of lenses, it will be plus V by U. Understood? It will be plus V by U. Done? And this is same. It will always be equal to height of image divided by height of object. That is it. Done, beta. Now in this case also this thing remains the same. If the magnification is positive, it is virtual and direct. If it is negative, it is real and inverted. Done. And in this case we don't have a negative sign. Then beta, one important thing that is left is your power of lens formula. This is very simple. You just have power of lens. How this lens I am holding, this is lens I am wearing. So the ability of these islands to actually converge or diverge the light rays, refraction, refractive index, bending, something, ghanti. So the power of this lens to converge or diverge the light rays is called power of lens, right? It is inverse of the focal length. The focal length we studied, it is just inverse of that formula, P equals to 1 by F. That means the degree of convergence or divergence of light rays achieved by a lens is expressed in terms of its power, and its SI unit beta is diopter. The power of lens is defined as the reciprocal of its focal length. Now make sure to remember that if 1 by F, you have always focal length is in meters. If focal length is in centimeters, then the formula will be 100 divided by focal length, that is in centimeters. Understood? Great. Okay, now let's move on to some of the very important questions of your lenses and refractive index. We are done with the whole part. We saw concave lens, we saw convex lens, we saw refraction through glass slab, absolute refractive index, refractive index. Let's just quickly before that revise the formula of refractive index. That is basically what beta? Refractive index bacha N21. That means refractive index of medium 2 with respect to refractive index of medium 1, and velocity is simply the inverse of that. That means V1 divided by V2. Okay, and beta, this is also equal to sine of angle of I divided by sine of angle of R. This is the one formula of refractive index that you have to remember for the whole class length. Okay, out from this no question will come. Okay, let's see the question. Okay, light enters from air to glass. Okay, light is going from air to glass. Done. Having refractive index of 1.50. Now, how you write that? See, in the medium in which the ray is going, that will be written first. That means glass and air. That means when light is going from air to glass, so refractive index of glass, because of the glass the light is bending, right? So refractive of index of glass is on which our whole bending depends, right? So refractive index of glass with respect to air, refractive index of glass with respect to air, and it is given as 1.5. Understood? What is the speed of light in the glass? We have to find what is the speed of light in a glass. This is what we have to find. Okay, this is what we have to find. The speed of light in vacuum is also given. So we are given with the speed of light in vacuum or air. Vacuum and air at your level are same. Okay, it is given as 3 into 10 raised to power 8 meters per second. So all these things are given to us. These are all the given things. Okay, let's do the solution. Ma'am, we just saw one single formula, that is your this one. Now can I take out this part? You can take out these parts. Okay, you can take out this part, you can take out this part, you can take out this and this part. Okay, you can do all the permutations and combinations. Now beta, let's take out this part. Why am I taking out this part? Let me show you. I am given with refractive index of glass with respect to air. Okay, so refractive index of glass with respect to air can be written as refractive index of glass with respect to refractive index of air. Understood? And now velocity is inversely proportional. N1, V1 is on the numerator side. So V of A divided by V of G. Now what you are given? You have to find V of G. So we will find V of G. You are given with velocity of in air, right? That is given. So this VA is given, that is your 3 into 10 raised to power 8 meter per second divided by V of G is something we have to find, and this whole value is this one, N of G into A, that is your 1.5, already given, 1.5. Done. So now beta just calculate this. What we will do, V of G is equal to 3 into 10 raised to power 8 divided by 1.5. Cut it, 2. So V of G equals to 2 into 10 raised to power 8 meters per second, and that beta is your final answer. Done. That beta is your final answer. Actual velocity of speed in glass was 3 into 10 raised to power 8 meter per second, but velocity of, okay, this was velocity of light in air, and the velocity of light in glass comes out to be 2 into 10 raised to power 8 meter per second, 1 unit less. So can you see the velocity of light in glass decreased as light went from air to glass, because the refractive index of glass was higher than refractive index of air. Did you understand the whole line? Okay, great. Okay, let's move on to the next question. Okay, we have some question of lenses. What are it? A concave lens. Again, we will follow the same pattern. Remember, we followed a little while earlier in case of mirrors. Okay, what is given? Ma'am, given is simply a concave lens. Okay, a concave lens is given. Now see, the things have changed from concave mirror to concave lens, but focal length, the sign of focal length we just studied remains negative only. Okay. Now a concave lens has focal length of 15 centimeter. So focal length is minus 15 centimeter, which is given. At what distance should the object from the lens be placed? Okay, now we are asked the object distance. We are asked the object distance, where the object should be placed so that it forms an image. Image is given, object is not. Okay, so where the object should be placed so that it forms an image at 10 centimeter from the lens. 10 centimeter from the lens. Now what we have to figure out here? Beta, we have to figure out one very important thing. That is, see, your concave lens is given, right? So my friend, what is your concave lens? It is something like this. It is similar to convex mirror. Convex mirror just have two cases. Concave lens will have two cases. It will have two cases. It will always forms virtual and erect image. But in case of lenses, virtual and erect image is formed on the left hand side of the lens, right? In case of mirror, it was the other way around. Virtual and erect image was formed on the right hand side. But in lenses, virtual and erect image will be formed beta on the left hand side of the lens. So your V will be of negative sign. Understood? If you remember, this is your concave lens, concave mirror, right? And the last case, virtual and erect image was formed, and virtual and erect image was formed on this side, right? It was formed like this. Correct. So that is your stupid case. So this is your virtual and erect. In case of mirror, the virtual and erect image is formed on right hand side. In case of lenses, virtual and erect image is formed on left hand side. So for left hand side, all the sign conventions are negative. Done? Great. So beta, this is sorted. We just have to calculate. We just have to find out U to find. Now beta, what will you use? Ma'am will use mirror formula. And that's how your marks will get cut. Because this is lens. What is the difference between lens and mirror formula? Just a small stick. Okay. What is your lens formula? Ma'am, my lens formula is 1 by F equals to 1 by V minus 1 by U. In mirror formula, there was a plus here. In a lens formula, there will be a minus sign here. This is beta your lens formula. Done? And this is your solution. Understood? Okay, great. Now beta, you just have to fill the values. We have F, we have V. I can easily find U. I have 1 by F. F was what? Minus 15 centimeter. Minus 15 centimeter equals to beta, equals to 1 by V minus 1 by U. So that is your 1 by V minus 10 minus 1 by U. Understood? So 1 by U beta, the minus will remain with U. Okay, so it comes out to be here minus 1 by 15, and this minus comes here on the opposite side of equal to, that will become plus. Simply take an LCM, that will be your, how much what will be the LCM? It will be 30, right? So minus 15 into 2 is 30, 2 into minus 1 is minus 2, plus 10 into 3, 3 into 1, 3. That is your 1 by U, that is also of a negative sign. Done? This is simply 1 divided by 30 equals to minus 1 by U. So U comes out to be minus 30 centimeter. Again, do not forget the units. Do not forget your minus signs as well. So U comes out to be minus 30 centimeter. And beta, this was your concave lens. Oops, concave lens. Now U is always negative. So negative part is correct. So our calculation is correct. Understood? That is your one question of lens is done. Let's move on to another question. Okay, one very good question. The glass slab we studied, right? Just now we studied glass slab. Let's see what's the actual, what kind of question will come from that. Okay, in your laboratory you trace the path of light rays through a glass slab. Okay, we are tracing, you probably have done this experiment as well, right? So we are tracing the path of light rays for different values of angle of incidence. So it comes like something like this. It will come something like this. This will be your first incident ray. Okay, then beta, at this point you will make a normal. Done, ma'am. Then from this normal, again this ray should have gone this straight, but it bends towards the normal because this beta is your rarer medium, this beta is your denser medium. Now again you will make a different normal at this point again, right? And ma'am, this will be, now after this ray is coming out, it is going from denser to rarer. So it will bend what? It will bend away from the normal. So instead of going straight, it will bend away from the normal. And if you extend this very ray beta, these two rays, the incident ray and the emergent ray are parallel. This is your incident angle, this is your refracted angle, and this beta is your emergent angle. Okay, we have few conclusions. Now incident ray is parallel to emergent ray, incident angle is equal to your emergent angle is incident to your incident angle, and you can clearly say it is bending towards the normal. So refracted angle, angle of refraction is less than angle of incidence or angle of emergent. Clearly, can you be see, this is a bigger angle, this is a smaller angle, this is again a bigger angle, and E is equal to I. So if it's R is less than I, then it will be less than E as well, right? That is what your MCQ is. This is the whole concept of glass slab. Okay, so I is more than R. That is true. Angle I is more than, okay, not this one, angle I is more than angle of R. Okay, but nearly equal to E. I think we have found the correct answer. Okay, then I is less than R. No, this is not true. I is more than E. No, they are equal. I is less than E. No. So this first option beta is your answer. Done? Understood? Very easy. Okay, next question we have beta. Oof, a big question, and it has come in 2018, 2022, 2019, 2015. Oof, big stakes, high stakes. Focus. A student focused the image of a candle flame on a white screen using convex lens. The very thing we will write down beta is, ma'am, a convex lens is given. Other things I don't matter right now. Okay, convex lens, which focal length is positive. Its focal length is positive. Okay, done. Next beta we have, he noted down the positions of candle screen and the lens as under. Okay, position of candle is 12 centimeter. Now beta, you have to see one thing very important from here. All these distances are from origin. all these distances are from origin, and you will see how. Yes, okay, let's see position of candle. So position of candle, your candle is your object, right? Candle is your object. So position of candle is 12 centimeter from origin. All these distances are from origin. And how will I know that these are from origin? I will tell you that. Let's not write U, okay? So let's write position of candle. Position of candle beta is 12 centimeter. How will I know from origin? I'll tell you. See, position of convex lens 50 centimeter. Earlier we take U from the convex lens, but now convex lens is at 50 centimeter. That means, and that's how we know that these distances are actually from origin. So convex lens is placed at 50 centimeter. Okay, then beta we have position of screen 88 centimeter. Position of screen beta is 88 centimeter. Now you have to use your brain a little bit. What lens is this? This is a convex lens. This is a convex lens. It has 6 cases. And mostly in first 5 cases real and inverted image is formed. In one image we have virtual, and in one case we have virtual and erect images. Until here it's clear. Now beta see, this candle is our object. This candle is our object, and see, this is your convex lens. This is your convex lens placed somewhere. Okay, let's say somewhere. Now, okay, this is your origin, but let's not say somewhere, you will get confused. This is your point of origin, and this is your principal axis from the lens. Okay, now this is your origin. So convex lens is placed at 50 centimeter from the origin, right? See, let's read the numerical again very carefully. A student focused the image of candle flame on a white screen using a convex lens. So one thing is clear, that my object will be on left hand side, then there will be a lens, then there will be an image that will be an inverted image again. This is the main, this is the, what do you say, juice of convex lens. This is the overview of convex lens, how the proper normal image is formed. U is on the left hand side, V is on the right hand side. Now beta, white screen using a convex lens, he noted the position of the candle screen and the lenses as under. Now these positions are from a certain point, let's call that as origin. Now they are saying that this lens is at 50 centimeters. This lens is at 50 centimeters, but there is one tricky part. There is one tricky part, that this actually, this can be from which side, on which side of origin this lens is placed. That's where this comes in. You try to make this whole thing again. What we will do, we will not place our origin, we will not place our lens on the left hand side of origin. Let's place it on the right hand side. Let's see what happens. Okay, so beta, this is your origin. I'm trying all the things. Okay, you tell me which is better. Now if this whole thing will come here, this whole thing will simply just come here. Now this is your 50 centimeter. Done. This is your 50 centimeter distance of lens. Okay, now distance of candle. So your candle is on this side. If I would have done that origin, your candle will be here on the right hand side, right? That doesn't make sense. So that's how you think. Okay, so now beta, your candle is what? It is 12 centimeter away from this origin, and lens is 50 centimeter away. Now screen is 88 centimeter away. Now again it makes sense. So screen is 88 centimeter away, somewhere here, somewhere here. Let's say this is your screen. Okay, and the distance of screen from this point is your 80 centimeters, 88 centimeters. Done? Understood? Now let's do some basic math. Now let's see what is U and what is V. Okay, now this screen is placed at some distance from this mirror. This hole is 88, this hole is 50. Then what will be this left? 80 minus 88. 88 minus 50, that will be your 38 centimeter. This distance from lens to the screen. From lens to the screen is what? That is your V. From lens to the screen where the image is formed, that is your image distance, that is your 38 centimeters. Done beta? Understood? And it is on the right hand side of the lens, so it is positive. Now beta, this is 12 centimeter, this hole is 50 centimeter. So from this object to this lens, what will be the distance? 50 centimeter minus 12 centimeter. 50 centimeter minus 12 centimeter, that will be your 38 centimeters. So your U beta is 38 centimeter but is on the left hand side of the lens. So your U is 38 centimeter and is on the left side of the lens. That means negative sign, and you can clearly see these distances are same. That means your candle beta is placed at what? Radius of curvature. That means whatever this screen is also placed at radius of curvature, because this is also 38 centimeter, this is also 38 centimeter. Object distance is equal to the image distance, and that happens only in one case, when the object is placed at radius of curvature. Done? Understood? How you think about it? A little bit tricky, a little bit hard. I won't even say tricky, a little bit hard, but as soon as you see there is a position of convex lens, then you have to use a little bit of your brain. You start from the very basic and then you build from there. Done? Okay, now beta, what are the questions they have asked? What is the focal length of the convex lens? You just know that this V equals to U. That means this is radius of curvature. So radius of curvature is 38 centimeter. It's a convex lens, so it will be positive. So focal length will be what? 38 divided by 2. That will be your 16 centimeters. Done? Understood? 16 centimeters. So this one beta, we have the answer as 16 centimeter. Then where will the image be formed? If we shift the candle towards the lens at a position of 31 centimeter. Now they are saying it was 12 centimeter. If I shift the lens, if I shift the candle towards the lens at a position of 31 centimeter. See, now if I place this somewhere here where this 12 centimeter becomes 30 centimeter. Let me show you. Now candle is placed somewhere here now, and this position from this origin to this candle is now 31 centimeter instead of 12. Now what will happen beta? Look, this means what? That this U becomes what? 50 centimeter minus 31 centimeter. That is what? That is your 19 centimeter. Right? 19 centimeter, correct? So your U comes out to be, now this is a second case where your U becomes minus 19 centimeter. U is the distance of object from the lens, right? Now we have placed this candle at 31 centimeter from this origin. So this candle from lens will be what? 50 minus 31. 50 minus 31 is what? 19 centimeter. Done. So your U comes as minus 19 centimeter, and where will the image be formed? Now we have the focal length. We have the focal length as minus or plus 16 centimeter. You have U as minus 19 centimeter. I want you to do the calculation using what? Using lens formula, 1 by F, 1 by V minus 1 by U, and write down your answers in the comment section very fast. Okay, quickly write down your answers in the comment section. Done beta? Okay, great. Next question beta, we just have 2 more questions left and then we are done with the whole big chapter. Okay, a convex lens. In the starting only it's given, the given part is what beta? It is given that we have a convex lens. What is the focal length of convex lens? Beta, focal length of convex lens is positive. It forms a real and inverted image. So we are also given that it forms a real and inverted image and of a needle at a distance of 50 centimeter from it. The image is formed at a distance of 50 centimeter. So we are given V of 50 centimeter. If it is real and inverted in the case of convex lens, then will the V be positive or will the V be negative? Ma'am, we have 5 cases in which the image is formed on this side of the lens. This side is right hand side is positive. So image will be positive. Done. Next beta, we have where is the needle placed in front of the convex lens. So we actually have to find U. We have to find beta U, and if the image is equal to the size of the object, we are also given with that image. See, a convex lens, if the image is equal to the size of object, that means height of image is equal to the height of object. Also find the power of the lens. Okay, this is a ridiculous question, because when they give us this height of image equals to height of object, everything else vanishes. We just have to do one thing, that now beta, if this was concave lens, then matters would have been different. But this is convex lens. Convex lens has 6 cases. It is forming real and inverted image, and in that case height of image is equal to the height of object. That means your object is placed at radius of curvature. It is placed at radius of curvature. That means it is equal to mv. Right? If it is placed at radius of curvature, then means image distance and object distance are same. Image distance and object distance are equal. So if V is 50 centimeter, U will also be 50 centimeter. Correct? Wrong. U will not be 50 centimeter. It will be minus 50 centimeter. It will be minus 50 centimeter, because U is always negative. And why we reached to this conclusion? Because of this small detail, height of image is equal to height of object if the image is equal to the size of the object. Okay, so we have U, we have V. That means radius of curvature is also this, that is your 50 centimeter. It's a convex lens, so it will be positive. So focal length will be what? 50 divided by 2, that will be your 25 centimeter. 25 centimeter. So your focal length beta will be 25 centimeter. We have to find the power. That's why we are finding focal length. So focal length comes out to be 25 centimeter. And beta, what is the formula of power we just studied? We studied that power is equal to 1 by focal length. But that's the case of meters. We have here in centimeters. So what will we do? This in centimeters, that means 100 divided by F. Remember this formula. And 100 divided by 25, it will be simply 4. So power will be 4 diopter. Power will be 4 diopter. Cool. Cool. Great. Let's move on to the last question of today's big one shot, and that beta is your one final question. Let's see if you can do it or not. Okay. What is given? Given is a 2 centimeter tall object. A 2 centimeter tall object. So height of object is 2 centimeter. Done. Placed perpendicular to the principal axis of a convex lens. So we are given with convex lens. The focal length is, sign is positive. The sign of focal length is positive. Of focal length 10 centimeter. So focal length beta is plus 10 centimeter. Understood? The distance of the object from the lens is 15 centimeter. Distance of object from the lens is plus 15 centimeter. Minus 15 centimeter. Good. Minus, if you actually caught that mistake, very good. Minus 15 centimeter. Now done. Find the nature, position and size of the image. So we just have to find nature. We have to find the nature, position. Position yani position means V, right? And size of the image. Also find its magnification. Basically the whole first chapter of the lenses part. Okay, great. Now let's move on to the solution. Beta, first thing is we have to find V. To find V, we will use lens formula because it's clearly a lens. If it was a mirror, we use different formula. Remember that. So 1 by F equals to 1 by V minus 1 by U. Understood? So beta, 1 by F is given as minus 10 centimeter. F is given as minus 10 centimeter. 1 by V we have to find minus 1 by U is given as minus 15 centimeter. Minus 15 centimeter. This minus minus becomes plus. Plus 1 by 15. 1 by V equals to minus 1 by 10. Understood? Then beta, 1 by V is equal to minus 1 by 10 minus 1 by 15. So let's take the LCM again. 30. 10 3s are minus 1 into 3 minus 3. 15 2s are minus 2 equals to 1 by V. So 1 by V comes out to be minus 5 divided by 30, and V beta comes out to be minus 30 divided by 5, which cuts to 6. So V equals to minus 6 centimeter. Minus 6 centimeter. Let's check first if our V is correct or not. How will we check? Ma'am, this is a convex lens. For convex lens, first 5 cases V is real and inverted. That means it has positive sign. It should have positive sign. But it should have positive sign. Okay, there is some mistake. Let's quickly go through this again. Plus 10. Okay, I did a mistake. It should be plus here. Okay, my mistake. See, a live example of how you can catch your mistakes if your concepts are clear. Okay, so this will be a minus. Okay, this whole is gone. This done. Okay, let's see. The focal length was positive. Plus 10, and then there will be no negative sign, only a positive sign. So 3 minus 2 will be 1 divided by 30 equals to 1 by V. So V beta is simply 30 centimeter. Now let's understand the logic we were using again. Ma'am, it's a convex lens. Convex lens, first 5 cases are real and inverted, and in those the image was formed on this side, on right hand side. That means, and those were the cases when U was greater than focal length. U, this is focus, and U was behind F, right? Somewhere here. U was behind F. That means U was greater than focal length. U is greater than focal length, 15, 10. Yes, U is greater than focal length. That means V should be on right hand side. V should be positive. So is V positive? V is positive. V is 30 centimeter, and hence beta we have found the position. Now what is the nature? Ma'am, it's convex lens. U is greater than F. So it is real and inverted. So nature is real and inverted. This you can see without even solving the question. U is minus 15 centimeter. F is 10 centimeter. So U is greater than focal length. It is placed behind the focus, not between focus and pole, because that's the only case where virtual and direct image will be formed. But it is not that case. It is the first 5 cases. So it is real and inverted. What is the size and magnification? Let's find the magnification. Now beta, magnification is simply minus V by U equals to height of image by height of object. Now height of object is given to us. It is 2 centimeter tall. So it is 2 centimeter tall. Height of image we have to find. Beta, minus V by U. This is also given 30 centimeter. U is 15 centimeter. Minus 30 centimeter. Okay. One thing also. Remember, we have magnification formula for lenses as plus V by U. Remember that always. Okay, I have not used in the last, right? I got confused. Okay, good, I have not. Now V is what? 30 centimeter. U is minus 15 because U is always 15 in any case. Height of image we have to find. Height of object is given as 2 centimeter. Now beta, this cancels out as 2. So height of image comes out to be, this minus will be with this minus 2 into 2. So beta, height of image comes out to be minus 2 centimeter, minus 4 centimeter, and that is your final answer. That is your final answer, height of image minus 4 centimeter. Done? Okay, great. Now beta, minus 4 centimeter means, minus means it forms on the downside, downward of principal axis, and it is a little bit enlarged because of the height of object. Done? And we also had to find magnification. Just magnification is simple, minus v by u. Again, it is not minus, plus. So this was 30 centimeter minus 15 centimeter. So this was 2. So magnification is minus 2. Now beta, it was real and inverted image. It was real and inverted image. That means real and inverted image, magnification should be negative. Is our magnification negative? Our magnification is negative. So our answer is perfectly true. Okay beta, okay, we are done with the whole chapter. We started with mirrors. What is light? Actually, we started with that. Then we moved to optical instruments. First was your mirror, concave mirror, convex mirror, and then in that we did so many cases, so many ray diagrams. Remember that there is a video separately uploaded for just ray diagrams. Go watch that as well if you want. Okay. Next beta, we moved on to refraction. We studied refraction through glass slab. Okay, we studied about refractive index. We studied about absolute refractive index. We did a question on them as well. Then we moved to lenses. In that lenses, we also did concave lens, convex lens, and we did so many questions on them. Now, your homework is to revise the ray diagrams and do the NCERT exampler, the numericals. Okay, so beta, this whole thing prepares you for your PT test, for your half yearly test, for your boards. Nothing will, I quote and I say, this is my promise, nothing will come out of this chapter, nothing will come out of this lecture that your Aditi Ma'am has put for you on this channel. Okay, that is it for this video. I'll meet you in the next one. Subscribe to the channel. Bye.